Bello? 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 Why is this here? Move in a better spot. There's hair on me. There's hair on me. Hello. Bello, as we say in stream. Is the music really quiet, or is it my ears that are really quiet? Well, I guess my ears are always quiet, but I mean, you know what I mean. You know what I mean. You know what I mean. Hello. Ascend the ground and reborn. My hair is doing something, and I don't like it. Stir it up tonight. How are we doing? How are we doing? We've got very exciting music right now because we're gonna play some very exciting. We're not gonna play anything. I misspoke. I instantly was wrong. Instantly, which is like, it bodes well for a show called Hopefully Accurate when the first thing I say is already wrong. No, it's a good sign. It's a good sign. Um, so we're gonna be doing more science again. I've got my pen. I'm gonna write shit down. Um, Make sure you're watching both here and Wheats because we're gonna be we're instead of the way we used to do Uncertainly Accurate with which was I write things and Wheat was just kind of there. We're both gonna be writing things down. It's mainly gonna be Wheat talking about things that he's learned. And then what the fuck is this? Why do I just have this? Where'd that come from? Hello? I have a string. So Wheat is gonna write stuff down, and I'm gonna write stuff down on my end. So if you want to watch both, watch both. It's important, you know. That way you get everything. And there's a multi-stream. I think that one still works, right? So let me check. Actually, we need to update that command, but JFusion's not. Accept cookies, sure. Oh god. I don't want any sound. Anyway, there we go. If you want to see both, you can do that. I'll just watch Wheat as well on my other monitor. And then the plan is, okay, here's the plan. There is no plan. It's just my desktop capture. There you go. That's it. There is no plan. The plan is I asked Wheat this morning, okay? I was like, am I also streaming? Is this just going to be on your stream? And he was like, why are you doing admin before the stream? I was like, okay, fuck off, I guess. I think it was more a Wheat thing of being like, I hate you, I don't want to talk to you, and actually leave my house right now. How did you get here? Um, you know, which is fine, I guess. I guess. Oh god, he's started calling me. I'm scared. Okay, let's pick up. Hello?
Oh, brilliant. That works.
Oh, I can hear you twice.
Like, I can hear you.
Yeah, it's
Twice.
because you picked up on your other.
Fuck.
You fucking
Okay, there we
papega.
go. Sorry,
Incredible.
I muted that when I tested, so I thought it would just work, but no,
Oh
of
my
course
god.
not. Right, the lighting is fucking terrible.
You're a bit quiet.
I'm moving around all over the place. It will sort itself out.
Fucking hope it does.
Okay, we're just gonna go with that light. I like that. It's nice and dark and pleasant. I can actually just turn myself up like this. Hang on. Ignore that. Are you sure I'm quiet?
You sound alright now.
Okay. I'm gonna say I'm loud my end. Anyway, there's that, and then I need to go here. Share, brilliant.
Oh, I have. Oh god, you're sharing your screen and everything.
Yeah, I know. I need to do this. Right. Then I have
Do you?
that, and then
Sure. You know
pop
what?
that
Sure,
out.
you do.
Get rid of that. the fuck do I make this right? That I need like there, I guess. Why? That's brilliant. It's already detected that. That's because normally that would be your face. Um, I still have the old science window,
Oh.
and it's actually like got a good idea of what shit should be happening.
Does it have a good idea of what shit should be happening?
I mean, everything was exactly as I left it. Uh, if
Thank
you
you for
were
the
in the same place,
follow.
I could have just left it alone. But there's no
I'm
guarantee that
not
you are.
because well I could be. I could be. Right now I'm just on my standard desktop capture.
Yeah.
But
So I needed
what
to
we
like.
could do is of course do this. Go to this one. Oh look, it's capturing the popped out window
Yeah, yeah,
of
yeah.
oh yeah, I see. Okay. But I
Okay.
don't want
So
to
that
I don't actually want to share your stuff.
no.
I don't actually give a shit about any of your stuff anymore, so I'm
Oh,
getting rid of it.
okay, fine. Do you even like? Are you even gonna put my face on yours? I
Maybe if I have to. I mean, right now
mean, you
your
don't
stream is
have
just
to.
starting soon anyway, so
Yeah, 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 yeah. I'm not ready.
actually,
Uh,
oh, I heard it, champ. Oh, sorry, I had desktop audio muted because I was listening on Wheat's stream earlier to see if he was saying anything. I'm sorry.
oh, I can just leave that called Redox Discord, can't I? That's fine. Oh, you don't go there.
Okay, well we can
Fuck.
move around some stuff. Okay, I
What's
have
that?
too many of these
Redox
boards.
View. I don't need Redox View anymore. Delete.
Yeah.
Brilliant.
So what I was thinking, right, is I said this earlier to you. Instead of having I mean I only need one. Well, I guess I can have your face as well. So uh instead of having both our like things that we're writing and both our faces, we just have what we're like our own screens that we're writing on and our own face, and then if people want to see the other notes,
Yeah, they
they
have
have to
to.
go to the other Twitch channel.
Pretty good. Like,
So
well,
that
this is
way,
my setup for now. Um, finally.
now we can
Like,
see it. Perfect.
and
Okay,
then.
I'll change some stuff around. Yeah, we could probably make this. Oh, I fucked it.
And
I
then
fucked
what I
it now.
need, because obviously I need that to be the front window, which is a bit of a pain. So what I need to do here is, hey, anyone got a multi-stream?
Yep. My old command still works for it.
That I
Why
can
is this
just click
border
on.
thing? Why does it have like such a? It's terrible. I'm deleting it. I don't need it. I only need this one. Which one? I
Right,
need this one.
actually, like, I've had such a fantastic idea. Um, I can add um that add source Redox view. It's still fucking there. Brilliant. I can add it. There we go. And then right, check this. If you're doing like the same thing as me, then
Am I doing the same? Okay, sure. You know what?
well,
Okay,
if you
sure.
copy my layout, right, then
Yeah. Someone do exclamation mark admin in the chat, please.
bam,
I feel like
bam.
I'm way lower on this one than I am on.
Because it's a bit of a pain at the moment. Obviously, everything's bouncing around all over the place. But in like an ideal world, I have that and that. But how do I then? Oh, I just need to not have it maximized, don't I?
Wait, I have a genius idea.
Like that.
You know where I used to forget to
What the
write the
fuck? Why has it got so
question?
big?
You know where I used to
Oh, it's
forget
because
to
the
write the
monitor's bigger.
question? I can just write the weekly topic now because we're only gonna have one topic. It's gonna be so much nicer.
Yeah,
What's my hair
there
doing?
aren't topic. Well, there are kind of topics now. Oh, hang
Yeah,
on.
it's
Transition.
astrophysics.
Yeah.
Is the topic every week,
Yeah.
and then I'll never have to change it ever again. It's
I can ditch
perfect.
that. Right.
What is this? I have so many. What are you? If you wanted the Yummers logo, I could have it. Chat. I don't want chat. I don't want that.
Okay, so
This
the
is from
problem I
old
have
versions.
is now that I have a bigger monitor, um, when I full screen something on that bigger monitor, it kind of fucks things up. So I have to be a
Mhm.
bit. clever about this. Okay, if I leave that there and then
Wait a second. Where did that come from? I
where did
found
what
you.
come from? Oh,
Oh, I found. Okay, there we go. I knew I still had this somewhere. Okay. This is weird. This is so stupid. We're so stupid. Why are you like? Why are you like this? Why are you so small, huh? You
because there's a
small
lot of
little
information going
man.
on. This is a fucking. This isn't. This isn't about us. This is a fucking lecture. I don't know
No,
if
but
people
look
are
how
expecting
small you.
comedy here.
I'm expecting comedy. It's fine. I'm here to bring funny. I'm just gonna widen you because otherwise you won't fit in the box. There we go.
It's been a while since Wide as 9 came along.
There we go. It's perfect. It's perfect. Oh, and Iva's still got a handful of bosses. Topic
Right.
in they she he they. So true. Okay, there it
Now,
goes.
like, you see, this middle thing at the bottom is the top part of your screen. So just with our faces cut off. Uh, and it's like
Okay.
fucking perfect. So, like, if you start writing on there, it's visible. Now, the problem I have, right, is
Why is
this.
your top part so fucking
Yeah,
horrible?
that's because
Why is it
I am going to
so?
periodically have to
Oh, is it just
restart
because your
my.
tablet screen share is just real bad quality?
Well, it's fine until it's not. It's because I'm doing it over Discord. So periodically, I have
But
to
how? I've.
uh, stop sharing my screen,
Wait. You know what?
and
Oops.
oh,
Oops. Oh,
that
I
would have
didn't mean. I
bounced.
didn't mean to leave. I meant to. I meant to stop watching your screen, but you closed it just before that, so I. So it went to the disconnect button instead.
Nice.
um. Why can't you just
You
use
get to see all my apps
Weed's
every time I do
Discord
that, but now
facecam?
it's
Because
fine.
we don't do because Weed's Discord facecam breaks all the time.
True.
Um,
I think it's actually my screen share that does that, but whatever. And now I need a Redox face view, which I'm pretty sure I have here somewhere. I also deleted
it
that.
should be
There's one
somewhere on
here.
there.
Yeah. It's
Exactly, Shark Dog. See, Shark Dog gets it.
window
So what
capture.
exactly is the topic for today? Well, actually, you know what? We'll get to that later. No, I don't even
Yeah, we'll
answer.
get to that when
Don't
I
even answer
actually
that. I don't
know
even
the answer.
care.
Yeah, that's true.
New and improved. Listen, J Fusion. J Fusion, I have a job for you. Okay, I needed. Look at the screen. What? Look at what screen? Hello? Why is why are you? Oh, I was like, why is your
Shut up.
the topic is day sheet? Yes, I know that. Shut up, champ. I just suddenly saw my own chat on your face. I was like, what? The fuck? Okay. Why is already DMing me fucking shit? Oh my god. Okay, you know what? While we
Fucking
wait,
perfect.
we're gonna look at some memes
I'm
that Wise
done.
sends
I
me. This
finished.
is the transphobic. I mean, I need to fix my shit as well, actually, because I need to fix my display capture to be actually centered. Oh, wait, you're a bit higher than I am. Which is
Am
this
I?
one?
Fuck. Well, I'm also a lot wider than you are because some of us are rude.
Yeah. Oh, I just want this one and this one. It's not like aligning it, so it's kind of hard. Whatever. We're just gonna assume that's correct enough. Why does Wheat look like his forehead? That one scene from Jimmy Neutron where Sheen gets a gigantic head and shoots electricity out of it. Well, because Wheat didn't want a large enough square, so I made him larger. I made him wider
I was
to
making
fit.
room.
No,
That's
you were
fucking
too small.
That's too fucking big.
Anyway, just found out my rat can type on my phone. Ask her questions in the comments. Bonnie, what do you think about trans people?
Oops.
Whack love.
Oh, fuck's sake.
Anyway. Admin. But yeah, JFusion, I need your help because it's impossible for me to do this myself, so I'm gonna have to ask you to do it. Can you change the uncertainly accurate command to be not about sending in questions, but about just how we're talking about science, and you can like because we still need it for the um for
Oh, for
the
fuck's sake.
like to link to the multi-stream. You'll still need
Wait,
to link to the multi-stream so that people can watch both of us if they want. Have you made me thin? Is that what you've done?
no,
Or am
no,
I
no, no,
just
no, no.
thin?
I'm having some difficulty. I accidentally made us both they she and then both he they. I'm trying to make them different.
You fucking. Oh yeah, yeah. This is Wheat's
I don't
coming
normally.
out
I
stream.
don't know.
Wheat now goes by
Honestly,
they she.
after what I was on about in the whole last night, I think
Do
I
you want to
deserve
talk
this.
about that? Okay,
I
go
think
on.
so. Yeah, we'll do it. So right, okay.
Okay.
So last
Anyway.
night, right, I was lying in bed not doing shit. Um, apart from Tinder, and I was like, I'm curious what's the competition here? Like, what do most men's profiles look like? So as you do, so I opened up um the settings to everyone rather than just women, and when I
Mhm.
did this, I had 4 likes. When I 5 minutes later, I had 10 likes. This morning,
Okay.
I had 20 likes, and now, and I've turned it off. But Jesus Christ, it was a
Okay.
real eye opener, I suppose is the word you would say. Um, we gay Tinder will
Sorry.
snap you up. It was true. What the fuck? Oh right, yeah, that's I was genuinely thinking, is this an edited picture of me?
Yeah.
Sorry, I need to get my stream back up on my phone. I was
That
just
is
looking
just
at Tinder
you.
again.
Um.
Right, there's that.
True, champ.
I need to like,
But also, yeah, gay men are just horny,
yeah, that too. I need to not be
and not only
they
gay
she.
men.
How do I fix this? I guess I need to make a new one. Fuck that.
Did do you not understand how to make a thing to like what? What? Hello?
Look, all I did right is I did it for you, and then I copied it so that it made a new one, and moved that to me, and then changed the text. However,
Yeah. So just.
um,
Oh, I
that
guess
didn't work.
copying
No,
might
that's not
be
what I
weird.
put in there. That's the name of it. I've called it Wheat Pro. I nearly made my pronouns Wheat/Pro. Right.
Yeah. Wheat slash bro. True. I just made it one thing, and I just added a lot of spaces in between them, so they're spaced out.
Oh, for fuck's sake! Now I've moved the entire
It's just how I've done
background.
it. What have you? What?
That
What do you
move.
mean?
No, stop it. There we go.
Wheat pro. Anyway, so Wheat was saying, I
They're
mean
different
that Wheat
sizes.
is your
Fuck's sake.
pronoun in a way. I guess our nicknames are kind of like our pronouns. You know, Wheat
Sure.
is his noun.
Right.
No.
Now the
Wheat's
quality's
getting
gone
paid
again.
for this one, so it's his pronoun. Anyway, keep sending me memes until Wheat is done.
Hang on.
Now we can laugh at them and laugh that it's that. This making me shark dog. Yeah.
I'm ready.
Dog.
We're ready to
That's your
go.
name. Oh
Right.
my god, we're ready to go.
Pretty much. For fuck's sake, that's gonna. Oh fuck. Okay. One last thing. I need to have another window which has the content in it. Which I didn't think far enough ahead for.
It's okay, champ. We can look at your meme. What is this? Is not a meme. This is Jimmy Neutron Wiki. It's not a meme, champ. Big Brain Sheen is the genius alter ego of Sheen Estevez, who appears in the episode titled Sheen's Brain. After an experiment gone horribly right, done by his best friend Jimmy, Sheen's intelligence continuously increases, only for it to be discovered that it will grow infinitely. Due to this, his brain, along with his head, begin to slowly but quickly expand, thus giving him strong, godlike brain powers. Oh, I remember this episode, actually. That's Wheat right now. Why does Wheat look like Why is your camera quality like you're on Omegle and you're about to like
Because my camera's
whip
shit.
out your dick? Slowly but quickly. Is that what it said? Wait.
I'm changing the
Oh
lighting.
yeah.
No, that's
It
worse. I
does
don't
say.
like that. I'd prefer. Look, this is my
I
fucking vibe.
the problem is
Okay.
that is because I've made it wide, it makes it look like that. You know? I think I'm right. I think I'm right. No
Yeah,
one can tell me
yeah.
I'm wrong.
That's what's done
You
it.
being wide doesn't help. Because on
No.
your stream it's less bad.
Yeah, that will be what's happened to the
Oh my
quality.
god, I scored a
Anyway,
drop. Claim now.
what's the last thing that I need
I claimed a
is
drop.
not that.
What's oh. See?
That's
And
not the
if
right one either.
agrees. Slowly but quickly. I do love slowly but quickly, it's good. Wheat's fucking face. Someone take a fucking screenshot of Wheat just sitting there fucking a wide ass looking ass. Oh my god.
Okay, I need that, and I need one more thing. And then I'm totally ready. I'm fucking unstoppable after this.
Yeah, I don't know why they didn't translate energy. But everything else was translated. That's interesting. I always forget that Shark Dog's Dutch as well.
Okay, we're fucking ready to go.
Oh my god. Pog, should I have a background layer? Ugh, I'm kind of sad we lost all the. Maybe should
Oh,
I
I
should
should
I?
hang on. No, I should save that.
Nah, you don't need to save anything.
It's a good thing that just like this only shows the drawings I've done, which are purely work related. You know, screen share could have been a fucking nightmare, but no, because I have only done work on this and I can't draw, so there's no like
I don't want it.
artistic
What about that?
expansions, shall we
Jeez.
say?
What? What kind of
What the
what
fuck does that
what are you
mean?
even saying? Are you
What the
okay?
fuck does that?
Are you
Right,
having
new
a
drawing.
stroke? Okay, we're doing this.
Okay,
This color.
the bloody quality's gone again, so I need to restart this. Why is this gonna happen so often? Like that, like it's a Chromebook, so I can't like just connect it and have it work like that. Like there's fancy ways of making it work, but this ain't it. Everyone gets to see my apps.
Oh, I need
which
to
again,
change that one as well because I'm
unfortunately,
not
I don't
capturing
have
his
any.
drawings
What the
anymore.
fuck? Why has it gone here?
Legends. It's just because we're superior, Shark Dog. That's why. And I guess we'd learn how to spell better. I don't know.
Wait, which one is this? Which window is this? No,
I
not
thought
that.
we were
This one.
ready. Any more memes?
Redox Discord. Sorry, I'm just hiding that because I've just noticed I have a second tab open. Okay, yeah, that is just the same thing. It just wasn't entirely
Yeah, because
sure
I'm
what
not
that
capturing
might be.
his drawings anymore. This is a different one. That's not the command, I think. Because that's the one that's on loop and
We're
the
ready.
actual. We need to. For some
Why
reason,
the
we have
fuck
two
does
of
it look
these.
like that? Why are there
Can we make it
squares on it?
one that is like a bit more concise and just like you can watch, you can look at Wheat's.
Right. Oh, fucking hell. Welcome. Our first topic is.
Wait, say this as I'm typing it. Wait. Okay, go.
Sorry, I'm still on the rubber. Cosmology.
Cosmetology. Yeah.
Yes, we're studying makeup.
Okay. There we go.
Would you believe the
Cosmetology.
lecturer made that joke himself? Amongst astrology in the same sentences.
Of course.
So,
Of course they did. Because they're also funny like me.
yeah, of course. So, like, I've been thinking, like, what?
Oh, that's dangerous.
What do I actually want to do in this stream? Is the question. And I thought about it, and I thought, you know what would be good to go through? The workshop questions, right? because they'll have answers already provided, so I can't fuck up. And this way, it is also good revision of things I did 3 weeks ago. I figure,
Okay.
like, if I try and talk about something I've just learned, like yesterday, which is not a lot to be honest, because I didn't have anything yesterday.
it, I was gonna
Then
say
I'm
it was
just gonna
Sunday,
be
but it wasn't
chatting
Sunday. It was
shit.
Monday yesterday.
I'm just gonna
Um,
be chatting absolute shit like this week. So
you shall
tomorrow,
anyway. Okay, so I'll be chatting absolute shit. Anyway, it goes to do it anyway. Go
no.
on. Yeah. No, go
So
on.
tomorrow, and not tomorrow at all. So I was chatting shit. Uh, Thursday, I'm
Yeah.
well.
To be
Tomorrow
fair,
I'm
we used
doing
to do
my
this on Wednesday, so it makes sense. It makes
yeah.
sense.
Tomorrow I'm doing my not assignment, some exercises on fluids. Either that or I'll do my cosmology assignment, which is probably more important, so I'll probably do that. And but say I did fluids and then I wanted to talk about fluids that day. I'd be spouting so much nonsense, and then
Spouting,
all the
get it?
while that I'm doing that, I'm
Fluids.
uh, embedding that wrong knowledge into my mind more and more. So what
That's
I
true.
should definitely not do is talk about shit that I don't know
Anyway,
I'm
we're
wrong
talking about
about.
fluids today, so
We may
what?
briefly discuss something about fluids, but no, we won't. I don't know shit about it. Okay, so
Cosmology.
yes,
What
so
does that have to do with logs? Champ, are you
what the fuck are
okay?
you talking about logs for?
Champ's having a stroke in chat.
Hmm.
Um,
Anyway, the first thing we're gonna do for cosmology is fluid dynamics in space.
in
Um,
space, in space.
in space.
Okay,
The first thing we're going to do is talk about cosmology, and the first thing, excuse me, and
off to a great
and the
start.
first part thing for cosmology we're going to talk about is pretty simple, just distances. Okay, because that's
Pog.
a pretty important thing. You're dealing with things that are pretty large scale, but
I'm gonna act like I'm
how do we
writing my
work
own
out this
notes.
scale, and how big is that
Oh
shit?
god, I need to get. Yeah,
So the first thing that we're going to look at is the standard unit of measurement in cosmology, which is the megaparsec,
meters.
MPC. That's right. The cosmology is filled with MPCs. So you
Mega
have
parsec. Is it small PC? Small p. Small pp.
uh, small pp.
Big M. Small p. Small c.
Yes, big M, small p, small c. uh,
Okay.
so cosmology is not astronomical units because that is far too small scale. Cosmology is more galactic distances than
Okay. So first
solar
of
system
all,
distances.
what is an astronomical unit?
An astronomical
That's the
unit
distance from Earth to
is
the Sun, right? Right?
it's the distance
Yeah.
from
Okay.
Earth to the Sun on average. Um,
Okay. Which is
so
good,
it's clearly a
but not.
P. There we
It's
go.
not.
I didn't warn
This isn't
people.
M.
The initial thing I wrote for this that I was going to put on Twitter is sorry my handwriting is bad.
Oh yeah, mine's as well.
But hopefully by not using joined up writing, it will be clear. So, and I'll zoom in a lot while I
Joined up
write so I can
writing.
have more specificity. So, to begin, we look at 1 AU, which is 1 astronomical unit, which is the average distance between the Earth and the Sun, which equals roughly, that should be, there we go, 1.5 times 10 to the power 11 meters, which is
Okay.
a long way. It's the distance from the Earth to the Sun, would you believe?
Damn, it's
uh,
like we just said that.
so there's that. So to begin, 10 to the 6 parsecs is fucking big. So the first thing
And a
about
parsec
is,
is.
yes, exactly. How do
There we
we
go.
determine what a parsec is the first
Okay.
question. That's what we're doing.
Yeah. So
So,
okay. So the idea of cosmology is we're doing very large scale things.
yeah.
So we like talking about distances between like solar systems and between shit like that. So like
Not like distances between galaxies
between
and stuff like that.
galaxies.
Like I
Yeah.
can't remember. I'm sure it will come up later. But the distance between say, the Milky Way and Andromeda is, I think, about 10,000 megaparsecs. It might be more.
Okay.
But that's why you use that as
So,
your unit of distance.
do you know how long the Kessel Run is?
It was about 13 parsecs, wasn't it? 12
Well,
parsecs.
I think it's usually more, but then the whole thing is that he did it in only 12 parsecs
Mm,
because he took
yeah.
a shortcut.
Yeah.
But also originally they wrote it just as if it was a time thing.
Can you
But it's
fucking make me
not.
not wide?
No, you're too thin on your own stream, and I can't make you like if I make you like it will just wait. I need to
Fine.
make you
You know
really
what?
thin.
Look.
Make you really
No,
thin like
that's not
that.
how I do it. No, I can't do it. Nope. You're fucked. I'm being you're making me wider. Fine. Just zoom in on the top of my head so all I am is a brain.
Okay, sure, we can do that. Yeah, there we
Anyway,
go.
so the first thing that we're doing is working
Wait,
out
we need to.
what
There we
is a
go.
parsec. So parsec is defined as, if I can find the exact terminology, because I don't want to fuck it up. I know roughly what it is. Okay, this will be a bit of writing. So, one
I
parsec
haven't written
is...
anything in ages either.
I was wrong. 1 megaparsec is the typical separation between galaxies, not 10,000. It will be 10,000 regular parsecs, I suppose. No, it'll be 100,000. Shut up. Okay.
Whatever.
Do.
So how are we defining a parsec? Because we needed a larger unit.
Is
the
equal
idea.
to the distance from the Earth and the Sun, that is, at which the radius of the rotation, so 1 AU.
This is why he asked for Wise.
Subtends, I will define that word later because I had to look it up at the time.
You're a sub-10.
Subtends an angle of 1 second of arc, and that is equal to 1/3600th of a degree. Because it's small, because you have, fuck's sake. You know, the best thing about this view is that these headphones leave a red mark on my head where I leave them for a while. So if I adjust my headset and keep looking down,
you'll see the line.
Every time I do it, you're just gonna see the red line, and it's gonna be a fucking nightmare for me. You see? So there you go.
You asked for this.
I did. Well, no, actually, I didn't.
You literally said, "Make it my."
I still look wide. I'm still wide on that screen. I said not wide. Anyway. So how is this actually a thing? Is the question. So I'm going to define that now. So this is basically what happens when you get this situation. So here is one end of what we're looking at. So we're going to split it in half because each of these is 1 AU. So this is 1 AU and this is 1 AU.
He's
this
also
is
just looking down. So like...
This is the Earth going around the sun, and it has both sides of shit, and it's doing shit. It's orbiting the sun. So it's actually going around like that, but you take it at once a year. So you take the two ends of the orbit. And then, so when we say it's subtens,
the quality's really shit again, just so you know.
Fuck's sake, I need to restart.
I can't fucking read anything, any of that.
Return to call. It only takes a second to fix this every time, but it's... There we go. Use my finger to do that rather than the pen. Winky face. Don't know why that's a winky face.
I don't know either. It's just a very weird.
1 AU, 1 AU. And then we have this line here, which is going to form part of the triangle. This is 1 parsec. Actually, no, we're calculating that, aren't we? So ignore that. But that comes later.
Okay,
Here's our
so
triangle.
can we restart for a second? Because you've been saying a lot of shit and not actually saying a lot of shit. Does that make sense?
Sure.
So, go, let's go from the start again.
So, this is the thing we're doing. So 1 parsec is the distances at which the radius 1 AU subtends an angle of 1 second of arc. So when it's saying that, this is the radius 1 AU. So this line here is the end position of the Earth going around the Sun. So I've drawn a circle on that temporarily. That's the Earth going around the Sun. We take 2 positions, so once every 6 months.
Okay, so we've got the sun in the middle.
Yes, here's the Sun,
Okay.
woohoo. And
I'm gonna
here's
draw
the
this.
Earth, tiny. And it's going
Sun
around the Sun,
here.
and it's formed that situation.
Got the Earth over here, and it's going around in a circle like that. And then this. So yeah, so the distance here is an astronomical unit. Is 1 AU. Obviously, that's the same because it's a circle, so it's a radius. So that's the radius. And then this distance is where this angle is 1 arcsec.
Yeah. Yeah, and then you just treat it as a right angle triangle and calculate it like that.
What
And
is
then
an
you get this.
arcsec?
It's 1 over 1,000. Sorry, 1 over 3,600 of a degree. So an arc minute is 1/60th of a degree. An arc second is 1/60th of that. So it's essentially 1 over 60 squared. So it's the same thing.
So it's a very small angle.
Yeah.
Basically, it's just a very small angle.
Yeah.
That's specifically 1 second in the arc dimension.
Yeah, as Champ says, someone 1 parsec away would see the Earth and the Sun
1
arc
arcsec
away
yeah,
from each other. So
exactly
say someone here
distance.
is looking at it, they would see this situation, assuming that it's we're at exact perpendicular to it. I need to.
And then yeah, you have
again.
this right angle triangle with a side of 1 astronomical unit.
Yep, and you have the angle. So
the bottom is the one you're looking for.
Yeah, and that comes out.
Oh yeah, and you also have this angle alpha, which is 1 arcsecond.
Yeah, and then that is what we define to be 1 parsec, which comes out equal to, if we work this out, 2.06
so we need the tangent
times 10. Yeah, I forget which one it is. To the 5
so it's
astronomical units, which is roughly equal to 3.1 times 10 to the power 16 meters, and 3.3 times 10 to the power 1 light years. I didn't need that last bit. Sorry, the actual question deals with it in megaparsecs, so I had to take 10 to the 6 off each of them.
Is it not just this? Let me do math.
That seems about right. What did I do? Because I actually answered this. Oh, you can actually just do it in radians as well, which is a bit easier. So in the example, they just do, what is that? S equals R theta, which is that.
Yeah,
so you essentially just do
radians are better, but
1 AU times what is it? It's 1 in that case.
Yeah, champ, basically. But it's good because we're learning at the same time. It's we doing their homework, but we're learning.
Just so I make it abundantly
How much
clear.
is 1 astronomical unit? That's what I need to know.
I wrote that. That's 1.5 times 10 to the 11. My bloody thing keeps losing quality very regularly right now. I don't think there's any way I can fix that.
Fuck off with your miles, champ. Use normal units like normal people, you fucking freak.
So I think that that is equal to that as well, which I've just put there in radians. So 1 AU
How
times
much was
1
it?
over 60
1.5
squared.
times 10 to the
Uh,
11th?
in astronomical units, if we, oh yeah, sorry, yeah, astronomical is 1.5
And
times
that's
10 to the
meters,
11th.
I'm assuming. Or
Yeah,
kilometers. Meters.
meters,
Meters.
yeah.
Yeah, why would it be kilometers?
Yeah.
Okay.
Sorry, I was dealing with it just in terms of AU to begin with, so because I'm a
That
cheat. I'm the kind of person
that
who
probably
would
is
just,
easier to be fair.
yeah. I'm just the kind of person who uses C throughout all their equations and then puts it on at the end.
I mean, it's just easier. So yeah, makes sense.
It also removes any sense of scale, is the issue I've been told about. You can be working stuff out in terms of C and then have no sense of like what your other numbers as you go through it represent, which
I
can be
see.
confusing.
But also, I think it helps because like it's like comparing speeds to the speed of light is good for like
Yeah, it's like
relativity speaking.
yeah, most people will just use C, and
Mm-hmm.
there's no reason not to. Why have I've gone lower? You
So
ready for this adjustment?
what I'm getting in meters is 3.094. Let's just do it at that times 10 to the 16th. Is that correct? Am I doing my tangent
That sounds
correct?
right because I wrote 3.1 times 10 to the 16.
Yeah, that works. I mean, I'm assuming the 1 is exact and the 1 over 36,000. Well, we're putting that in as exact, so technically we could just. Because they're the only things we actually use. Are, yeah, meters.
There we go. A slight adjustment has been made. So yeah, there we go. That is the definition of a parsec and by extension a megaparsec. A megaparsec is just 1
Megaparsec is
times 10
just. Yeah,
6.
take away the 6.
Yeah, there you go. That's it. That is a megaparsec. So it's a long fucking way, okay? It's what? 3.3 light years in a
Okay.
parsec. If
So
you're
we've
looking at a megaparsec, you're looking at 3 million years. So it's a long fucking way.
okay.
Redox, there's someone speaking Dutch to you.
Yeah. It's a noof. I love a noof.
And there we go. That is question 1. There's some more interesting shit around here. Okay,
I'm
there's another
assuming
question.
astronomical unit is like the average like the
average
distance
distance
between Earth and the Sun.
Yeah, 'cause
So
it varies a little.
so you can just flatten the ellipse to a circle because at this distance it would barely make a difference if it was at if you're like right. Surely there's barely any change. Well, actually, maybe there is because it's such a long distance. Very small
It
change.
depends how much variation you're looking at. Like, how much does the
Yeah.
orbit vary by? Not a lot. So
Yeah.
it should be fine. Oh, for goodness sake! I've got 2 Y's on my he they on your screen as well.
I know. I love it.
There we go.
He
they. Okay. There we go. Right. The next part of this is about the separation between galaxies.
Oh god. Okay. The fucking Empire from Star Wars.
Because we're continuing to look at distances and generally just get a sense of scale with this first part of the question.
Does this work? No. Okay, so we've got the idea of what a parsec is. We've established that now. Boom.
Yeah.
On to the next.
So essentially all we're doing here is a very simple estimate, which is a fairly accurate one. So roughly...
Maybe... Oh, that's what we should have called it.
What was
Instead
that?
of hopefully.
Fairly accurate.
Fairly accurate, yeah.
Yeah,
Like
it's more hopefully than fairly. I have more confidence in calling this hopefully accurate than fairly accurate. Okay. So
the Galactic Empire was famously intergalactic. Shut up.
there is roughly 1 megaparsec between, this is terrible handwriting, I apologize, between galaxies.
Always, or just
It's pretty uniform to be honest, but mostly what it says here is the typical separation between galaxies is 1 megaparsec.
But surely that's expanding because the universe is expanding. So surely that distance is becoming larger.
May well be. I'm looking at it today. Um,
Okay.
and like in I mean, yes and no. Like we'll come to that at a point later, but the expansion rate over the scale of megaparsecs is still only in the tens of thousands of kilometers. So
Okay. So
on
yeah. So there's bare.
if you're
Yeah.
yeah.
Okay. It's not
So if you're
expanding
looking
that
at
much.
galaxies close enough to consider how close they are to each other, it's not really going to change that much. So unless it's a massive amount of time, and yeah, like neighboring galaxies, because
Yeah. I'm
obviously,
assuming it like if.
because the situation is like you have
So are they like
galaxies
in a
like
grid then?
I mean, no, consider it more random than this, okay? This is typical. It's random, but also kind of uniform. Typically, there's 1 megaparsec between galaxies. But if you
But
consider it like
if
that,
you were
obviously,
to make a model of a bunch of galaxies, is making them in a grid a good model?
look, I
Is that what
haven't
you're
made a
saying?
model yet. I will do at
Is
some
that
point, but
what
I
you're
haven't done it yet. I
saying? Wait.
suspect what you would see is more something like
Just you
very
have things with a radius and then you orb them.
uniform distribution. So it would be more like this. I'm essentially drawing a bunch of triangles here, so everything's kind of the same distance away. Obviously, I'm losing senses of scale,
That.
but you get, yeah, or one
It's like,
huge boba and ped. I don't know it in scales of pedguins and
true.
bobas. I have a fear that it would be a very different number for each of them. So that's something to be aware of. If you're going to use humans, they do have very different heights.
They're not humans, they're goblins and gremlins.
Sure.
That's the size of one pedguin. And these are galaxies. That's crazy.
Depends like
Very
how
tall.
you're doing it, because if recent postings are anything to go by, if you measure it in units of Boba's ass, you're going to get very low numbers. So
True, yeah, it's only gonna be like 3 of those. That's
yeah,
true. It's
so
true.
you gotta watch out.
Better watch out. It's true. It is true.
Anyway,
Famously, Boba has a massive ass.
famously,
Yeah,
it's what she's
it's
known
what
for.
she's known for, yeah,
Yeah,
exactly.
nothing else. Um,
Nothing else, no. Her one redeeming quality.
yeah,
If
yeah,
there's any Bobas watching this, I'm joking. I
allegedly.
love you. You're great. Um, anyway.
So that's roughly the number of megaparsecs between galaxies. Also, the universe itself, the observable universe, I should say,
Mm-hmm.
observable universe is roughly 10 to the 4 megaparsecs long. Long is an
Okay.
odd word to use here. I should probably
Long.
use a different one. Diameter, it'd be a good one to use.
Okay.
But, I'm trying to really dumb it down for me. So it's
Yeah,
roughly,
apparently.
and also I've accidentally written 1.0 times 10 to the 4 megaparsecs
And that's
long,
the
which is an
entire
entirely different.
observable universe.
Yep.
That's how much is it?
That seems small. A megaparsec's big,
I mean, yeah,
right?
megaparsec is like another. How
Because
much? There was
what
about
that
one
means is that,
megaparsec between, and this is 10 to the fourth.
yeah. So essentially, say you look in a random direction, you're looking at 10,000 galaxies in the observable universe in that direction, and specifically that direction, and then add every other direction to that. So then the question here that we were answering was simply based on these two numbers, roughly how many galaxies are there in the observable universe, which is a pretty
Mm.
straightforward sum. You just have the average volume that a galaxy is going to take up and the volume
Yeah.
of the observable universe. So essentially, if you're dealing in megaparsecs, what you have
Is
is,
it a radius or is this a? Sorry.
sorry, this is a Good question, actually. I think, based on how they've done this sum, it's a radius, but
That's what Short Dog was saying of what you were saying, but I wasn't listening to what you were saying, so hope that helps.
how did I... Let me
What
look
did you
at how
say?
I
Say it
answered
again.
this before.
It's how much you like. It's how far you see.
So this is just written as the length scale of the observable universe. I'm not sure if that means this is how long it is or this is how far it goes. I shouldn't do that in that tab. How did I answer this? Let me go to my Google Drive to see how I did this, because I'm pretty sure I got this shit right. Because I'm pretty sure the sum is just 10 to the 4 to the power 3 divided by 1 to the power 3, which is just 1. So you just
Why is it
essentially have
going
10
to the
to the
power
4
of
cubed,
3?
because it's a volume. Well, actually, it's going to be something like 4/3 pi r
Oh, I see. Okay.
cubed.
You
Not
take
like
the
that. That's
volume
not
of
how
a
you write
sphere
that.
instead of to the
Yeah,
power of 3, but I guess
but they cancel
pi
out. So it would
is
be 4
yeah.
thirds pi
Yeah, you
r
add pi.
cubed times that. That's r, so that's the cubing of it. So get rid of that. So it's 4/3 pi times that divided by 4/3 pi times that. So those cancel out. So you just have 10 to the 4 cubed divided by 1 cubed. And that gives a something like 10 to
So
the
so
12,
isn't it just 10
11?
to the 4th? Yeah, it's just 10 to the 4th cubed is the
Yeah.
answer. Yeah.
Yeah. Sorry, I'm just going to how I answered this workshop 1 questions. Two. Not that one. This one.
Which I mean, this
Yeah,
is
it's
just
just
1.
10. But then also, like,
These two fall away, so the answer is just 10 to the
it doesn't
4th.
actually matter if that was radius or diameter, because they would also cancel out. No, they wouldn't.
No.
That's wrong. Ignore that. They wouldn't cancel out because it's cubed. But it's that. Okay. Is it that? Because I got the answer right, so I must have done it right. But I divided by 2, and then I look. The answer is 10 to the 12.
Yeah, which is just
Okay.
10
I
to the
know that
4th
this
to the
is
3rd,
correct. I'm just checking how I got that.
which is that.
So what I did when I calculated this in my solo attempt, I went, quality's gone again, need to reset that before I write this out. I really need to like reposition the camera somewhere so that when I look down, it's not just the top of my head.
Put your camera like on the floor, looking straight up at
Looking
you.
up at me through my crotch.
Yeah. Well, I say I get I
Fuck,
guess.
come on.
Use the camera on your tablet.
I could just stream from my tablet, I suppose.
Okay.
Anyway, no, that wouldn't work. That would be terrible. So, how I calculated this before was using everything I just said. We had 4 over 3 pi 10 to the 4 cubed. Pretty sure I did it like that. Over 2 was included.
Not a very
Divided
good idea.
by 4 over 3 pi 1 over 2 cubed. I wrote squared. I didn't mean to do that. There we go. And I did that. And that comes out as equal to 10 to the 4 over 2 cubed over 1 over 2 cubed. And then I did that and got the same answer. Am I forgetting how cubing works? Because that is equivalent to, I think, 10 to the 12 over 2 cubed, which is 8, over 1 over 8. So that would be equal to 10 to the 12 over 1, and therefore equal to just 10 to the 12. So I'm pretty sure it's the same answer regardless.
What are you
If I
saying?
do it like that. So like the dividing by 2 does also cancel out as you go through it, because it works like this. It cubes the top and the bottom of the fraction. So it's essentially 10 to 12 over 8 divided by 1 over 8, and those two cancel out, and so therefore it's just
Well,
10 to
it
12
only
over 1.
it just needs to matter as long as because we just need to be using both radius or both diameter. And
Yeah,
if
yeah,
it's
yeah,
not
yeah,
both, then you have a divided by 2,
yeah.
which at the
So
end of
if
the
you're
day is
looking at
not actually going to do much in a
so if you're looking at
when this is your
separation
magnitude
between
anyway.
galaxies, that would be diameter, because it would be the radius of one plus the radius of another.
Yeah, that's what I was thinking.
So they are both then diameter. So the radius, no, yeah, it would be okay. It's a confusing concept because it's not really a diameter in that case. Because, for instance, you did a drawing of the circles all around each other. What you'd actually be kind of imagining in that situation would be.
Well, yeah, I
I'm
did it
putting that back.
2D, but it's also 3D.
No, it's not even that. Like, it's what you would be imagining would be here's galaxy one, here's its
Okay.
separation, and then there's a bunch of galaxies potentially on that ring around it,
On that edge, yeah, I guess.
rather than like as you drew
Yeah, I
it.
mean the circles I was drawing was I guess more like half of that distance. So I'm just drawing tits, you freak.
But like, yeah, that kind of thing. So either way, it's a diameter because you're looking at a separation distance. But so
Yeah.
those are both diameters that were taken, and so I divided both by 2. But essentially, as long as they were the same thing, it's fine. If you look, so good to know. Separation is a diameter. Length scale is also a diameter. Is
If
it?
we do this,
I think that's right.
then we have.
I took them both as a radius, but they're going to
So
be
we can just
diameters
kind of
actually. So that's that.
cancel out, and it's the same. Yeah.
Right. So while I was doing this, I pasted the wrong answer in
Of course.
here and have defined it as something different. So we're now going to move on to more properties of the universe than this kind of thing. We've defined distances. Woohoo, isn't that exciting? We've defined the number of galaxies in the universe, which is 10 to the 12, which is, as they pointed out, very similar to the number of stars in a galaxy, which is 10 to the 11. So with that in mind, we're now going to move on to descriptions of the universe. So there are 2 main descriptions of the universe in terms of cosmology. I think it's the cosmological principle, which is
Okay.
the universe, this is one of them, is both homogeneous.
Homogeneous, as like normal people would say
How
it.
do you
Yeah.
fucking spell this? Look, it's been pronounced so many different ways over the last few days, even I've forgotten. Homogeneous and isotropic. Fuck's sake, let me write that as an actual C rather than O. Now,
Yeah. Why did you laugh after homo? Why is that funny to you? Huh?
because I knew Wise would say something. So, what we so
What does that
homogeneous
mean, weed?
homogeneous.
Homogeneous.
This means that
Is there an E in there?
in terms of the universe,
Is
I
it
don't
not just
know. I think so.
homogeneous? Googling
The
it.
universe is the
There isn't.
same. Whatever.
I read it correctly.
It's not a spelling test. Same
It's the way Wise.
everywhere. And isotropic means, any geniuses in chat? Shut up, champ. Isotropic means that
May he protect us from sin and let us slut our way to death. And also, sun and sun are the same word, so that's proof. Checkmate, atheists. Nice. Why is this wrong? Anyway,
isotropic is that the universe is the same in all directions. Now, these two may seem
Well,
Uh,
homogeneous is it's when when I hear the word homogeneous, I think like when you're mixing something, when you're mixing two substances, and you need to make sure all the
sorry.
entire like mix is the same everywhere, so it's the same average amount of like let's say there's little granules, there should be like the same amount of granules everywhere, and then it's homogeneous. So yeah, the same everywhere.
Yeah. Whereas
And then
isotropic is it's the same in all directions.
which is it stays if you spin it or something, like it's basically rotation invariant. Is that what it means, right? Am I stupid?
Uh, what it means is if you are in, say, a given position in the universe and you look in any direction, what you see is on a large scale going to be the same in every direction. That's what it means in this scale, in this context. This gives rise to one of the famous statements of cosmology, which is that there is no privileged. I can't spell that word. Privileged. Spelt wrong. I've ruined the quote, but it's fine. Observer. I think the actual quote is there are no privileged observers, but whatever. I've changed the tenses. Which means that wherever you are in the universe, you're looking essentially at the same bloody things on the large scale. So, isotropic, you would think, means that something is, well, how do you separate these two things? So, how could something be homogeneous but not isotropic? That's where scales become the issue. So, if you imagine yourself in a forest, say, with completely evenly spread trees and all that shit,
Mm-hmm.
uh, you then have something that is homogeneous. It's just trees everywhere. Everywhere around you is the same. However, if you start climbing a tree, then your view in the upwards and downwards direction is different to what it was if you're standing on the ground. And this is the same in any scale, even if they're infinitely tall. You've still changed your view by being in a different position along them. And your view of everything, essentially, something can't be isotropic if it has a kind of structured form, i.e., it has the preferred the term
Yeah,
is
if there's a
it has a
difference between
preferred
this or
direction.
that. Yeah.
And that preferred direction is not just for like physical things, that is also for magnetic fields, electric fields. Any kind of field could disrupt isotropy. uh,
Isotrophy is when you're losing it, I think. I don't think
that's
that's
definitely
that
something
one.
different. So if you start
Yeah.
looking in different directions and shit goes weird, uh, your shit isn't isotropic. But the universe is both, which is a good thing for sure.
Why motors
So
energies?
that was actually one of the questions. Give an
Freaky.
example of what could make the universe homogenic but not isotropic. Uh,
Yeah, so a situation where it would be.
sorry, that was actually based off my answer rather than the example answer. So, um, yeah, that it's the same. Is they use the example of a
Would an example
magnetic
be
field.
like there's all pulsars are pointed in one direction?
Yeah, because
Because
yeah,
then
I mean,
if they're all looking like that, if they're all which is basically the same as trees. So if
yeah,
you're looking in
if they
this
were all
direction, they're
doing
always
that,
like that. But if
then
you're looking in a in like you know what I mean?
yeah, but for that to happen, you would presume there would have to be something causing that to happen. So
Yeah.
yes, and also yes, but essentially the question then is,
Yeah, we
what is
just
the
said
bigger thing making that
racism
happen?
doesn't exist.
There are
Anyway.
no privileged observers. On the large scale, things can be different on the small scale. That's right. Now I'm saying that racism is a small scale issue. So,
Wow. I can't believe you've done this. Can't believe you've done this.
so there we go. I can talk about my last job now that I no longer do it actually. So my last job, because this is kind of relevant, was I was an admissions researcher for a university, which means essentially I look at how people did in school, how they go on to do at university, and a whole bunch of other shit involving that. You may have heard of, in the UK at least, access and participation plans. So I was involved in the writing of those in terms of a very data view of it. I never wrote a word of what actually went in the reports. I may have made some tables that went in them and prepared data that made them, but I never wrote a word of it. So that's what I did before this. And so there you go. Guess what? I know more about this woke shit than any of you. I can talk about it. So
Smoke
fuck you
rises
guys.
from the mountain.
Hi, Quiche.
Says the
Fuck
white
you too.
straight man. Yeah,
And
sure.
Gandalf
Yeah.
the
Hello,
Grey
Quiche.
rides to Isengard.
Anyway,
seeking
we
But
is
it
trying
actually
to
brings
claim
up-
that racism is a small scale issue, and that he's more woke than all of us. So
Look, I can
Um,
talk about merit for a while if you want.
Mario or whatever you said, yeah. Why is Wheat Pixel Man?
Because Redox has fucked up my camera.
I've done nothing of the sorts. This is just what your stream looks like to me.
My stream looks fine. You've scaled me up beyond the limits of my camera.
You're
Like, I
just
could do
too
the same to
small
you.
for the thing. That's the problem.
I could do the same to you. Fuck, that's
No,
your
you
border.
couldn't.
Hang on.
You couldn't. You could do
An
no
onion
such thing.
container?
Well, I
A
just
wooden
did,
Because-
bitch.
bowl?
No, you can't
A
because
plastic water bottle
No,
and
okay,
a
yeah,
paper
sure, but
towel roll.
it's just
And
I have
bags.
J
nice
from Space
size.
Just resubscribed voor 24
Jay.
mons POOPER sus Redox
got
2
audio
NB
in my
qua
ears
Pride
now,
Riot
so I can't speak
POOPER
anymore.
sus Redox 2 NB qua Pride Riot POOPER sus Redox
Do you
2
know
NB
why
qua Pride
I made
Riot
this narrow?
POOPER
To
sus
give
Redox
room
2 NB
to
qua Pride
your
Riot
screen on my
POOPER sus
screen.
Redox 2 NB qua Pride Riot
to do that.
POOPER sus Redox
But I
2 NB
did.
qua Pride Riot POOPER
I'm
sus
actually
Redox
really
2 NB
pleased
qua
with how
Pride
I've
Riot
done my
POOPER
setup.
sus
Thanks very
Redox
much.
2 NB
It does
qua
look quite
Pride
nice.
Riot
It does look quite nice.
POOPER sus Redox 2 NB qua Pride
Particularly
Riot
with, like, how
POOPER
you've
sus
got your
Redox
nice
2 NB qua
handwriting at the
Pride
bottom,
Riot
and then
POOPER sus Redox
I
2
come in
NB qua
with
Pride Riot
whatever this
POOPER
shit
sus
is.
Redox 2 NB qua Pride Riot.
Anyway, what was I talking about?
Anyway, so yeah, hello, welcome to the stream. For the last like half a minute, no one could hear what you were saying because my alert was going.
Oh, okay, great.
So
Great,
it's fine.
fantastic.
It's all fine. Don't worry about it. Anyway,
Fantastic.
continue. So we've learned that the universe is homogeneous and isotropic, which means it's the same everywhere, wherever you are in the universe, and when you turn or when you look or when you move yourself, it's the same in all directions.
Yeah.
So
Yeah.
if you, I looked up isotropic, and the definition is having a physical property which has the same value when measured in different directions.
Sure.
There you go. So if you're looking at like,
I don't think so, champ. So part 2 of this question is an interesting one.
adiabatic. No.
No, I am too small scale, believe it or not, to
Yeah.
matter. So there is likely not another me.
It's true.
So the next part.
Yeah,
of
the
this
universe
question
is
to-
diabetic, however, so please make sure you have a an EpiPen with you. Is that a diabetic thing? Is that an EpiPen still?
I'm tempted
It
to
is,
make
right?
this one chat participation-y.
Oh, okay. Yeah,
Sorry,
yeah.
I
Is this
said
an,
that
are we going
word,
to the next question?
I said that word wrong because I was writing graphically and I kind of blended the word in my head with the word I was writing.
Participation-y. No, I like that.
Participationally.
I like that. It's good. This film is
Demonstrate
not
graphically.
homogeneous and isotropic. No, it probably isn't. Isentropic.
Yeah.
I don't know what that means. Is a
I'm just
thermodynamic
gonna keep
property that
writing.
establishes the relationship between expanding fluid's pressure and density as a fluid flows through the differential pressure flow meter. I mean, obviously the answer is going to be no, but oh, that actually makes sense that it's isentropic. I just didn't actually think about the word. Are they taking the hobbits to isentropic? Yeah, they're taking the hobbits to hot topic. Frodo's gonna get a fucking dingus.
So the question is to demonstrate
And I was
graphically.
gonna... What do you mean?
What are you doing?
Do you
Like,
do that in
kicking-
Hot Topic? Do they give you piercings in Hot Topic? Sorry, go on. What is this? The next question? Are we going to the next
Yes.
question?
Yes, we're on to the
Okay.
next question.
Doing it like this for now. Okay.
So, what needs to happen is demonstrate graphically that if all observers see an isotropic universe, then the universe must be homogeneous.
Okay. Yeah, I feel like isotropic is a stronger property than homogeneous. Right? Because,
Yeah.
like, isotropic is like, it's the same everywhere and directionally.
Mm.
Because, like, surely for it to be the same directionally, first it needs to be the same just in general.
Well, the
Did
issue
they
with
give you
the-
piercings in Hot Topic is the real next question.
so the issue with the universe is that you can't see infinitely in every direction. Sorry, my voice changed rather a lot then due to a
Yeah, you
needed
did a lot.
croak. And I need to reset my stream as well. I'm getting good at this, he says, failing.
No.
There we go. It's back.
So the question is prove... Oh God, imagine if I could write, huh? Prove... Fuck me. I literally can't write. Prove if everyone... I can't write on this fucking tablet. It's the worst. I'm just gonna stop writing. Prove isometric. Then
So, unfortunately, the graphical answer didn't make it into the solutions for this note. There's a description of what it should look like, though.
it's not
Which
isometric,
is-
it's isotropic. It's stupid.
Consider 2 points at an arbitrary distance from one observer. I presume those are meant to be the same distance. So there we go. There's 2 points, and here's our nice observer. It looks like me. Isn't that lovely?
So this is what we're trying to do, right? If it's isotropic, then if it's homogeneous.
Yeah, isotropic everywhere.
Yeah.
So then we have a second observer for whom these 2 points are equidistant, and hence those 2 points must look the same. Oh, so there's so then there's an observer over here who can be redox.
We can't see your anything on your stream. It's just black.
What the fuck? Where's it gone?
I don't know.
Oh, I stopped. Hello? Okay, something's broke. Give me a sec. There we go. It's back. Fuck's sake. You can see all my favorites, all the football subreddits I keep visiting. Okay.
Hog.
Okay.
I can't
There's
just
that.
do this. Oh God, that's the wrong one to show.
Nice.
I meant to move this one.
So here's me, and I am observing. That's actually now in the wrong place. Let's move that to here. It's essentially what the drawing I drew earlier of triangles. So if I'm looking in a direction and I see this and that, isn't that nice? I see that. I'm looking in a direction, I see that. And then over here, because isotropy is that they look in any direction, it's the same. And then homogeneity is that they see the same thing. Redox over here is looking at me and just sees me as another one of these dots. Because on the small scale, on the large scale, I should say, I am.
You're so far
completely
away.
irrelevant.
How could I? Also, I mean, you're basically a dot anyway.
Yeah, I don't matter.
True.
Sorry,
I do.
I'm getting
Though.
all croaky. So essentially,
Very
me looking at
croaky.
these 2 points in the distance, I see the same thing as Redox looking at me and one of those points. And those 2
Yeah.
points will have 2 points over here to see the same thing. And if we keep this going and going and going and making it so that it's isotropic in every direction, so everyone, wherever they look, will see 2 dots off in that distance or whatever, then eventually what I will end up drawing is homogeneous. With the exception as I've drawn me and Redox in there, which won't repeat.
Yeah.
But
Okay.
because we
Yeah,
don't
that makes
matter on
sense.
the large scale, it's therefore homogeneous.
So like this observer sees these two at the same distance, and they're the same because, and the only difference is the angle. Boom, and then these see the same if they're looking like boom, 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 boom,
Yeah.
boom, 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 and then you just get this field of dots at the end of the day, which is homogeneous. Well, I don't know why I'm doing it as circles, but I guess that kind of works. Anyway,
So the
that makes
next
sense.
question is one that I'm sure we've heard many.
Where was the
times,
chat
but
participation in that?
I don't actually know. I thought they might want to say something, but they didn't. Like,
Yeah,
submit
chat.
your drawing.
Huh?
Put
Where's
put
your
drawings
participation in that?
in Redox's Discord
Well,
right
you
now.
need to ask the question and let us ponder it for a second before you just give us the answer. Sure.
We went off on such a tangent that I completely forgot I even said that. So
Fair enough. Fair enough.
So the next question is one that I'm sure we'll have thought of many a time. However, I'd never actually done the proof for it before, and that is, fuck, I've still got the rubber out. Time dilation.
Wait, before that, and there's a question: is the universe only homogeneous on a certain scale? If not, on what scale does that no longer apply?
It's a pretty big scale. Like, if you're looking just at local galaxies, it won't be homogeneous. So
Smoke
But yeah, but you have to
Yeah.
see it
rises
as
from
like the whole
mountain
universe,
dew.
right? Jack.
The hour
Hello.
grows
Yeah.
late,
It's gonna
and
be,
Gandalf
like,
the Grey
10
rides
to the
to
power
Isengard,
something of
seeking my
megaparsecs.
counsel.
So it'll be a fair way. Certainly beyond galaxy clusters, certainly further than you'd like.
Champ's writing a fucking thesis.
Nice.
Wait, I'll read that in a second. Hope you had good Overwatch. I was watching you, Jack. I was watching you. Hope
The
it
set
went
of
well.
all observers be denoted SO. Given any two elements in set SO, show that the number of observers that can tell that Wheat's forehead is large in this frame must be at least a member of the set SO. Also show that an observer must at least observe the one and only God, Jesus Christ, peace be under his name.
So yeah, keep going.
Such that Jesus is shoved directly up an observer, SE's asshole, show your work and provide at least one graph that shows that Wise is a pussy ass bitch.
It's a very good question. And I think the answer is yeah. So yeah, I think the answer to Emma's question is like you can't really look at the universe at a small scale, you know, because then it's not, you're not looking at the universe.
Yeah,
It's
and a
it's
small
like
scale in
saying,
the universe is a fucking big scale.
yeah, it's like saying, you know, you've got like a bucket. You've got, I don't know, like let's say you've got a bucket with balls in it. You have to look at the entire bucket to see if the balls are homogeneous. You can't just look at like this corner and like, oh, there's one ball here, but there's only a quarter of a ball here and a little bit of there. It's like, well, yeah, but then you can't give that, like in that small part, it's not homogeneous, sure, but does that matter? And also, like there are very large structures in the universe that have homogeneous properties, because you've got like galaxy into like galaxy cluster into like wall is a thing. Is that the next one?
Wall? I haven't
that-
gotten that far.
Um. Well, that's what we called it in Dutch. Yeah, the Sloan Great Wall is a cosmic structure formed by a giant wall of galaxies. Yeah, we only need to look at the ones that are relevant in the the scale. Champ made a very good point. Yeah. Anyway, what's the next question?
The question is by considering a moving clock consisting of a light ray bouncing between two mirrors, derive the formula for time dilation, which is something we've discussed but never gone through the steps for it.
Has
We've like
also
shown the
nothing.
drawing.
We've just like we're just forgetting space shit now for a second, and we're just going to a moving clock. Okay.
Yeah, sort
And
of,
time
but it's
dilation.
important. Like,
So-
we don't actually need to necessarily go through this. I might just go through like the initial step.
No, it's quite fun to like look at the setup because it's an interesting
It's fun maths as well, actually.
thing to look at. So let's say you've got like this. You've got these two mirrors, and there's a light beam that is bouncing between the two, right? And I think that it's a classic experiment, right? Because it looks cool, and when you're in the system of the clock itself, all that it looks to you as is this light beam is covering this distance, and it's the same distance every time, right? And even though the clock is moving, you're also moving. You're moving along with the clock. So everything in the background is moving along with the clock, and the thing is still going this distance. So let's just call that like distance. I don't know. Let's just call it A. Right? But then if you look at from outside of the clock's point of view, if you look from an outsider's perspective, the clock is moving to the side. So as the light beam is going, it's instead of like the clock, it starts here on this side, and then it hits a mirror over here to go back, and then it hits a mirror here. So let's say the light beam is instead doing this, and it bounces back, and it's going a longer distance, which we'll call B, which we can just math out, because this one's A.
Can you call it D, please? Because I've called it D, and
Sure.
A is L.
Sure. So A is L. This one's D. So, like, just from looking at a triangle, we know that D is the longest side because it's a straight. It's a like we don't even need to care. Like, this is already just a really interesting thing. If you're in the clock's point of view, in the clock's reference system, the distance the light travels is that distance, and it is constantly doing that L distance, right? Whereas, like, in one bounce, it does L. But if you're out of it, it does a longer distance of D. So, that's crazy. Like, how is it doing that? And all that is from just moving a light. That's a fish launching into space. Yeah, it's true. It's true. Anyway, Champ is answering Emma's question better than we ever could. So yeah, it's really interesting.
Yeah, sorry, I'm writing out the proof.
And it says that is swag, which is very nice.
So I'll go through this in a sec. There's a lot of it, to be honest.
Yeah. Well, we'll go over the proof in a second, because I'm assuming it's like the moving of the clock at a certain speed and whatever. Makes it a bit easier. Because we can just decide this distance to whatever speed the clock moves in one L in light time. We can decide L as well. You're doing it with big L's.
Yep. Oops, that's not right.
Small L's.
Yeah, it is.
That's not the right color. There we go.
Oh, of course. So I've done what I did before, which is I've included 2's everywhere, which I don't need to do. Um, but I've gone with it now. So essentially, this bit here, which I've just written, is background knowledge. And we'll come back to that when like people on your stream can see it. Actually, I'll just keep writing for now. It doesn't make sense to do it now.
Okay. And if it's always coming in and dropping straight facts, it's true. So yeah, this is the situation when you're in the reference frame of the clock or outside of it, and this x is the distance the clock moves in the time that it takes light to bounce from one side of the clock, from one mirror to the other. And then we can just, I'm just gonna do it like this, even though it is easier if it's different colors. Need a sci-fi game that takes place during the Andromeda Milky Way collision. That would be interesting. True.
Yeah, it would actually be very boring.
Yeah,
Because
I
not
mean,
much is
it
actually
doesn't
going to
move.
happen.
Yeah, it doesn't go that fast. Like on a large scale, large
I'm
time
not.
scale.
I don't.
It
I
looks
mean more on the
impressive,
sense of
right?
nothing actually like. It's called a collision. Nothing really actually hits anything. They're just kind of joined together.
Yeah, that's what I was thinking, champ.
Yeah, like the only like you could make something quite interesting in a sci-fi sense if you have like, I don't know, it's in the far future where there's a big human Milky Way empire and suddenly there's the giant Andromeda empire that comes and gets you.
Gets ya.
So you could do something with that, I suppose. But otherwise, not enough really happens. That's meant to be T1, I think. 4 plus e squared down to T2.
They accelerate as they get closer together because of gravity. I mean, yes, but also true, champ.
Yeah. I'm nearly done. It's quite lengthy.
If you want to see all that Wheat's written out, go to twitch.tv/Wheaters9.
Yep. T2 squared equals.
We're all just vibing until you've written this out.
Yep. 1 minus b
Thought so
squared
well.
over
Thank you for putting that twice. It's great.
t squared t1. Is that where I'm at?
True,
I think so.
champ. Which, I mean, that is a pretty cool setting for, like, a game. Like, there's a star that is getting brighter and brighter, and it's been happening for, like, centuries, and there's, like, religions about it and stuff. But then at some point, like, you know, like, temperatures are going up, and then, like, the tides start going weird because of, like, the moon suddenly, like, I don't know. Well, I guess the moon would still be vibing with us because it's too close to us. Yeah, but we'll just speed it up a bit more, you know? We'll just say it. We'll just say somehow humanity has survived.
Yeah.
You
So,
know? Like,
I finished.
we just teleport it closer a bit.
I've written the proof. Okay.
Okay, yeah, go on.
So, if we
So let's
start
go through it. But
here, this
slowly,
is the
yes.
picture example that essentially Redux gave. Using the D's and L's, we have the stationary clock with lights bouncing back and forth. Unfortunately, when I answered, it's got the picture's gone. Unfortunately, when I answered this before, used 2D and 2L. which cancel out entirely throughout all the equations, but it does mean that there's a bunch more numbers in mind that wouldn't
Why would you
otherwise
use
be there.
2D?
Because I was using light bouncing back and forth between the same point, so it goes up and comes back, and then on D you have it goes up and comes back as well. So I've got a longer triangle.
Okay,
then I
yeah,
split it
but
in
like
half.
if you only, yeah, like I was saying, like you can just use half. You don't need this. You only need one.
Yeah,
piece.
well, I was considering.
I mean, at the end of the day,
going out and
it's
coming
the
back.
same distance because it's
Yeah,
just
it
this
cancels
twice
out. Like,
and this
I'll tell you when
twice.
it cancels
like, it's
out.
the
Okay.
same thing.
Um,
So I think the important part that I've not looked at this side is the time part.
Yeah.
Um.
So essentially, what you're measuring here is time, not distance.
Yeah.
But
So I'll write it as my part. Which
distance
is
is
just
quite easily defined
the time
because
it takes.
you're looking at
in
something traveling at
one.
the speed of light. You have essentially the distance is
Well, not two.
c times t, the speed of light times the amount of time it took. So
Yeah.
using that, you just say that okay, well, the time that it took for a stationary clock to bounce back and forth is the length it traveled, which I've used as 2L. You could just as easily use L divided by C. And then when it's moving, you have T2 equal to D over C, which is this distance,
But then we need to find the distance of
the
D,
lengthy one.
which is, well, it's the
Yeah, but then you need to figure out what
of,
D is. Well, D is just using simple Pythagoras. It's D squared. Well, the Pythagoras equation is A squared. I'm sorry, A squared. Yeah, A squared equals B squared plus C squared. So when you get rid of those,
so
the
if you
square
get
root
the
one, you
square,
end up with
yeah,
this.
if you get the root
So
over it,
get D equal to L squared, which is just that side, obviously. And then to calculate this side, you just consider, well, it's the speed that the clock's moving at. So
yeah, which
and then you're looking at half of that because I've doubled everything, so I need to halve this one. Because I'm looking
so
at
what
this
is the
side
speed
D.
the clock is moving at? Because I've just called this like length x.
You just
like,
call it V, velocity. And also, you may remember that that's actually quite important for the final equation.
Makes sense.
So call it V. And so then you end up with D equals L squared plus a half V dt. And then that's all squared. Square rooted, all of that. So then you do...
D... Wait, but isn't... Yeah.
Then
Which
you
is a
do
bit annoying
bunch
because you've got D... Yeah. You've got
of rearranging.
You've got dt2 in terms of D and D in terms of dt2.
Yeah.
It's a bit annoying.
So then you do some rearranging using the fact that L equals C dt1 and D equals C dt2. My picture's gone again. Bloody hell. I'm trying to keep track of this. Come on.
Just break out the Lorentz transfer. Well, yeah, we're basically, that's what we're figuring out right now. But the main idea is...
Anyway, so would you like me to say delta, champ? Jesus Christ. Okay, fine.
Yeah, it's not even dt like you wrote it. It's delta t.
Yeah.
Because we is just being bad at it.
Being short about it.
Yep.
So then you can substitute using this bit here, delta t2 in out, I should say here, for the 2d over c, which if you didn't use 2's would just be d over c and make your life much easier. And then I actually simplified that down because I had the half in there, and so that cancelled out from there, and so it's just vd over c squared without squared in there, which is actually one of the few areas it's actually got more simple. So then you make your way down here, d equals L squared plus v delta t2. Is this homework?
Well, this is homework he's already done.
Yeah, like I'm not doing anything that I don't know
but
the
we're
answers
just
to.
we're
and
revising
also
it.
to me more. It comes back. Why did it come back?
I don't think. Where did you drop it?
Where did this come from? This 2 here.
I can't see what you're pointing at.
No, I drew an arrow. This one.
I see.
Where did that come back from? Did I do something wrong that got me to the right answer? Oh no, I substituted out D, so it came back. Okay. Yeah, so I substituted, so from here to here, I substituted in D.
This
so
is
turned
homework,
into...
Emma. Please write the answer down right now and send it to me now. But yeah, the basic idea is we have the two systems. We have the system of when you're moving along with the clock and the system of when you're not. We got 1 here and 2 here. Yeah. Which is, sorry, bring this down.
Anyway, essentially, this box in the bottom left is me substituting in this equation and this equation into this equation. Then in the top right, things have been rearranged a bit. The 4s have cancelled out. I then multiply everything by... No, I divide everything by t2 squared, delta t2 squared, because that's in all the terms except this one, which leaves us with this equation. Then divide everything by c squared, so this one disappears, this one turns to 1, and this one becomes v squared over c squared. Then rearrange it a bit, get this, sort it all out, and you end up with the final equation. That's it. Mathematical proof. May skip over those sections in future ones of these. Bam.
We're not assuming that, champ. Wait, are you talking about Wheat's thing, or are you talking about me not having, me only doing half a period? Because I think the one thing you know of is that these events of bouncing happen at exact the same time, right?
Yeah.
You know that this touch and this touch are at exactly the same time, and this touch and this touch. That's literally the basis of the experiment, is that they touch at the same time, so they have to be
from
moving...
the clock's perspective.
Yeah, from the clock's perspective.
Anyway, that's the proof. The final thing for cosmology to talk about is Olber's paradox.
Yeah. Sorry, basically, we put this equation... Sorry, we put equation 1 and equation 2 into this one. Yeah, but then okay, yeah, but that's true. But that's a whole... There's like a whole thing about how you can't really measure the speed of light, because you always get it twice, and there's a whole thing about that. There's I think, was it Veritasium that have I think they have a really good video on it, I remember, which is quite interesting. But yeah. Yeah, basically you can't measure the speed of light.
Speed
like
of
you
light
you
is the
always
same for
you
all observers.
like we have to assume that
Fuck.
like if you send the thing and it goes back, maybe it was a Vsauce video actually. Thinking about it now. Whatever. Anyway, that's not what we're talking about. But yeah, you're right. But also, practically, we're assuming the speed of light is the same in both directions.
I'm not necessarily going to write anything for this next one, because it's a brief thing, but
we're assuming the speed of light is constant in both directions. But yeah, from filling this in, we find... What was the equation that we find, because you got rid of it before I wrote it down.
Oh, it was T1 equals the square root of 1 over... Oh, sorry, that's T2 over 1 minus V squared over C squared.
Is it,
I think,
T or just delta T?
Delta, maybe.
Because I don't know how you suddenly come from time. Well, it could be.
Yeah,
but,
it's probably delta, yeah.
T2 over 1 minus V squared over C squared. There you go.
Which, we'll be familiar with. Boop, 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 boop.
If you struggle with like math, Emma, I think what really like a channel I really fucking love is wait, let me just Google it so I'm sure. Like to learn more is like about basic math and stuff is 3 blue 1 brown. They do really good math things. I fucking love them. They're really good, and they have really good visual explanations of just very difficult math things. And I think they have like a playlist with like basic math things explained and basic calculus explained and stuff. Did he? I didn't know that. I do quite rate Khan Academy as well. It's quite good. But three blue 1 brown, one of my favorite math channels ever. Yeah. He's very good at it. He's got like I don't know. The videos are very. He's got a really good way of explaining things and a very good visual style of explaining things. I think I really rate his channel a lot. If there is like if you're interested in math and things like that, but like the too deep math stuff is hard, like because there is some tough shit on there. Like it's not easy stuff, but I feel like he's very good at explaining it well and having good visual explanation of these things. Yeah, very good channel. I definitely rate them. Anyway, continue on, Wheat.
Well, the last question of cosmology is just a quick mention of what was known as, yes, it's gone now, Olber's paradox. Olber's paradox was back in 1823, which is roughly when it was written, which was if the universe is infinite and homogeneous and static, because they thought the universe was static at the time.
It's a name, I think, champ. Sorry.
Static being not expanding. Then why would the sky be dark? Because if it's infinite, goes on forever, in every direction, everywhere you look is going to end up with a bright light. And if it's homogeneous, then the further you go away, the more light sources there will be, which actually works out so that at every distance, an equal amount of light is coming towards you. Why is the sky not, the night sky that is, not bright completely? Because it's illuminated everywhere. That was the paradox. They didn't have an answer to that for a while. There were a few solutions. The main factor, as we know it now, is obviously the expansion of the universe, in that light from things that far away is
it's just never going to reach us.
Not reaching us. Even if you look at a static universe, as Champ says, the universe may be infinite and static, but time is still finite, even in that situation. So the infinite amount of light hasn't reached Earth. There's actually a lot of other stuff going on at the time.
So if you were in a static universe and you let time go to infinity, there would be infinite, like, then the night sky would be bright. Is that what you're saying? Because all the light from all the stars would have reached us.
Yeah.
Okay. That makes sense.
I wrote something else here as well. Oh yeah, I was just describing it. And also, another part of that, just going on to that, is that you may think that like dust blocking things would mean that, oh wait, no, not all the light will reach us, so it will still be dark even if it is that situation. But no, would you believe? Because gas clouds in the way would heat up and eventually emit the same amount of light as they were blocking. So it would have no effect.
Makes sense.
At the time,
I guess it would
one
just
of the main
disperse the light.
arguments was that the Milky Way was an island universe, because as back then and all the way up until like the early 1900s, the belief was that the Milky Way was an island universe and there were no stars outside of our galaxy.
So what? The Milky Way was the only galaxy to exist.
Yep, that's what they believed for quite a long time.
Interesting.
Imagine being one of the world's leading scientists in 1908 and thinking that there was only one galaxy in the universe. That was presented as a humbling fact in the lecture.
Sorry, I just
look
looked
how
over
wrong-
to your stream, and I saw your tags, and I saw you have Arbiter of Cishet as your tag.
Yes.
The fuck? Okay.
Yes, of course I do.
Okay, yeah, sorry, continue on. Continue on.
Well, that's it for cosmology. And would
We're
you
done.
believe that was the shorter one? Because I also had
I mean,
Galactic Astrophysics to go to.
Okay. That's fine.
I'll see if I
fine.
can speed run it, but like.
Well, we don't need to speedrun it, but we don't need to do entire proofs.
Well, fortunately, this entire questionnaire turned out to be proofs, which was a really frustrating thing.
That makes sense why it's so long then.
Oh, it wasn't even that. Actually, here's something that can help.
Literally, champ.
I've just realized I can use the answers I actually wrote for this. Isn't that a wild solution?
Is any of it doxing you?
Potentially, that's what I'm looking at.
Okay.
Well, that's my lecture notes.
So what is this about? What's the set the scene for us?
So galactic astrophysics is all about galaxies, would you believe?
Who could have predicted that?
And essentially how they interact and move about and whatnot. So for instance, the
whatnot.
first question was if I find the actual wording of it, because I didn't copy that into my questions. So it gives you the relationship between the velocity of stars and the density profile of a galaxy. So that is v squared equals g m brackets. Oh wait, this isn't the density one.
I'd assume Soma because of expansion of the
R
universe.
squared.
Slowly they'd move further and further away from each other.
I feel like there may have been an error in how that was written. It's given me it tells me it's giving me the relationship between the velocity of stars and the density profile of a galaxy, and then it hasn't given me the density profile of a galaxy. So I'm going to presume that this equation at the start of this questionnaire is meant to read that. Not what I said before, not what I wrote, and not what it says. Where P is a density factor.
So what you've written is
a radius.
The velocity, or is that not velocity? Because you wrote a capital V, but is that a capital
It's
V or not?
velocity.
Okay, so it's not a capital V.
I mean, that's a little v and that's a capital V. They're pretty much the same. It's just one bigger
Yeah,
than
but
the other.
that's why I write my little V's with a little dingus and a capital
Alright,
V
you
like that.
bloody French.
It's just more obvious to see which one's a capital, because you could be talking about potential energy.
You could.
Over here, actually. Speaking of which, this looks a lot like Oh wait, never mind. You got rid of the square.
Yeah, it wasn't meant to be there.
Yeah, I was gonna say with the square radius in the bottom, it reminds me a lot of the force between two like gravitational force between two objects.
Well, V is just well, apparently that's V squared. V squared is just GM over R is the equation that it's meant that you may be familiar with. Although I could have sworn that was just V equals GM over R, which is orbital velocity.
What is that G? What's that big G?
Gravitational constant.
Okay, we would write that with a small g.
Well,
over
we
in
never.
Belgium.
Yeah, we would never.
Wait, is it the one I'm thinking, or is it the other one I'm thinking? Are we talking about?
I have no idea what little g would be.
Sorry, it probably is large G. I'm being stupid. It probably is large G. I'll leave it as large G. If it's
anyway,
6.67 or something.
What's written on this page is that, which I find strangely confusing because I'm still not entirely sure what that is.
Is that
anyway? Maybe it'll
smaller than
become clear
R?
with the bits that come on.
Is
Yeah,
that just
I don't know
saying
what that means.
M is smaller than R?
I don't know.
What is M? The mass of.
I think that's. Oh wait, no. This is density profile. So this is essentially not saying density, but that is. So what that's saying there is the mass within the radius. So for instance, in a galaxy,
Yeah. Okay.
you have mass going
like in
outwards
this-
all along it. So the further out you go, the higher the mass gets.
Yeah. So let's say this R. We're only talking about this part. And that's what. And so M is only this part, not the outer part.
Yeah.
Is what that is saying. Okay.
Yeah. So this question was basically show the relationship between velocity and radius using these situations. Excuse me. So the first one was a central supermassive black hole, which is just a point mass. So you just use v squared equals gm over r. And so the proportionality would be v is proportional to the square root of 1 over r, and then you would plot a graph of that, which I think would be something like, fuck if I know, be something like that, I think. Something like that. Pretty sure the square root doesn't change that. Now we get rid of that because who cares anymore. The next one was an object with constant density. So, you know, a uniform system with something orbiting in and around it, which actually ends up with V just being proportional to R because of maths. It's actually pretty short.
Thank you.
Yeah. Essentially,
Okay.
you have.
But I mean, is there anything interesting to talk about that isn't just proofs
No.
using? Okay.
That's just maths. I can just tell you like those facts, I guess. I don't want to go through proving that again. And the last one was an object where density drops off as r squared, which was complicated, and the maths for that is showing me 3 integral signs as I go through it, and I can't be asked writing that out. And I don't think anyone can be asked to listen to me try to explain it either.
Sorry, we're not doing cosmology anymore, are we? We're now doing
no galactic astrophysics.
Galactic astrophysics.
Honestly, we might not do much of this. This was pretty much all equations.
Yeah. If it's all like I think it's more interesting to find out where those equations come from and stuff like that.
Yeah.
Also, Arnhall has a very important scientific question. Hello, Arnhall, please tell us. Pretend you're calling in. Hello, Arnhall. What is your question? Oh, hello, it's me, Arnhall. I'm from Wales. Why do they call it oven when you in the cold food out of out hot eat the food? Fuck me, I can't speak. Hello, I'm Arnhall. I'm from Wales. I don't know why my Welsh accent is Swedish. But you know what? I'm Arnhall. I'm from Wales. Listen, okay, you can't make fun of me. I'm just making fun of you instead.
Yep. So this is an actually important equation, which I'm just going to write. It doesn't actually do anything in anything that I had to do in this thing. It's just an important one, which is
Okay.
known as the NFW profile. NFW stands for people's names. I don't know
Okay.
what they are.
Come on. Whose
Nope.
names are they? Come on.
I don't know. Name a scientist beginning with N. Newton. Name one beginning
Newton.
with F. Friedman. Name one beginning with W. Fuck. I don't know. Let's see. I don't think it's either of those two either. So
Fuck's sake.
let's have a look. Navarro
So it's-
Frank White.
P is A cubed R times RTA squared.
Mm.
Okay.
Sometimes
go over
written
those-
with R being equal to R over capital RA, but I'm not entirely sure what that is. Or R over capital RS. In those cases, this one would go here and this one would go there. I don't know why. So there we go. We'll ignore that because I don't know what it means, and it
I'm
might come
assuming
up
those are
later.
constants that are not important.
They're definitely not constants because they have those suffixes. One is going to be the point at something, and another is going to be the point at something else. So
Oh, that makes sense. So let's go over what all of these are. What's P?
okay, P is oh, it's really confusing. P
The
stands for
profile.
density. I can tell you that much, because it always does. This is essentially a density profile. What? I'll just read you the first line of description for it from
Sure.
Wikipedia. The NFW profile is a spatial mass distribution of dark matter fitted to dark matter
what I
halos
was thinking as
identified in
well.
N-body simulations by one of the guys who made it. So in the NFW profile, the density of dark matter as a function of radius is given by this. So this P here is the density, but it's density of dark
So it's not
matter
a P
specifically.
It's actually a row.
Whatever. I always just write it as P, but you
Yeah,
can
but it
be
doesn't
fancy if you
have.
want.
It's a different letter. Capital P is pressure.
I'm not using
In
capital
physics.
P. It's clearly a lowercase p that I've written.
Well, lowercase p is non-existent.
And also that A on your second P is a suffix, not next.
Yeah, I know this is a suffix because it's PA. It's P. Well, is that also a row?
I think it might actually be yes.
Okay, so
I
that's
think it
also
might
a
actually be a
density.
P. Like Wikipedia's giving me a different equation to what I got in my lecture. It might be P0. I'm not quite sure. P0 would make more sense if I'm being honest.
D is usually displacement, yeah. Oh, it's a 0, not an A.
It's really distracting. Like I
makes
look
more
at your stream and it's my face is so big.
It's just what your face looks like, Don't be mean to yourself. The thing is, I don't have much space to work with. I can make this smaller. That's like, this is the best I can do. That's the best I can do for you.
I'll take it.
The fuck? And Niv is just like, I can't believe Niv is promoting his own stream in my stream.
Unbelievable.
Unbelievable.
This is some
S is
in-joke I'm not
displacement.
aware of.
D is usually distance as well. S is like if you're going for a path. D is a distance between two things. S is like moving, like yeah, whatever. Anyway, so what is this R? Are these the same R's? R's.
It's kind of awkward if I'm being honest, because like the definition on Wikipedia is completely different, and I'm pretty sure the lecture notes don't give definitions of what they are. This is something I need to go back to. Is what I know for sure.
Okay.
This isn't even really part of the question.
So you're saying next time you're gonna tell us what it actually is.
Fine. We'll come back to it. But essentially, it's an equation that you use to model dark matter in galaxies. Interestingly, like P0 isn't a constant. It's
Bro.
and RS, which would go here under weird circumstances, is also not a constant. Those are parameters which vary from halo to halo. Those being just things, physical features of a galaxy. The question was just to, well, the, the question was to take that and use that to prove that the mass is equal to another equation, which is very long. However, it doesn't even start from that point, so I don't know why they even wrote this down on the piece of paper. But there you go, it was there. Next question. Oh yeah, the next question was to make me use that in Python. No one in this class has ever used Python before in their fucking lives. So
What do you mean? Okay, so are we learning Python? Is that what we're doing now?
I am learning Python alongside that. I am not doing that in these because who gives a shit? Jesus.
What do you mean? That's interesting. Come on now.
Okay, I'm learning Python. Look, I'll show you. No, no,
Okay.
I won't. That will dox me if I do.
Fine.
I'm learning Python anyway, and I look at like the example solution of the Python code needed. Like I don't think anyone in the class actually did this. And they've written a bunch of shit. Like I don't have a clue what any of it means. Okay, so first of all, they import a bunch of things. These things don't exist. I don't know what they are. I don't know what these files are. One of them is called numpy as np. Like what the fuck is that? I've never even seen that file in my life.
NumPy.
What?
Why?
No.
What is it? Just import.
numpy.
Yeah, NumPy.
Fuck
That's
does that mean?
it's a library that you use for math in Python.
Well, there we go. Didn't tell us that.
Are you sure?
And then they gave us some
Adding
parameters.
support for large multidimensional arrays and matrices.
Nice.
There you go. That's NumPy.
And then
it's pi because it's Python.
Shit, and then they
numbers probably
plotted the rotation curve, and I have no idea what they did. I have no idea how they did it.
Okay.
And as far as I'm aware, it's never been addressed. So what the fuck do I know about that? I am aware that like Python is part of this module, but the only time it's been mentioned is in like that question. So it's like, what the fuck are we doing? And we meant it anyway.
Feel
enough
gay
complaining.
fast. Fucking me. I was like, what the fuck does that mean? Incredible.
Nice.
Yeah. Well, I'm sure if you do you have like a course on actual Python?
Yes.
A course on. Okay. Well, yeah, that's fine. You'll get it.
Yeah, but I electively chose that one. That wasn't a compulsory one. There's people doing this Galactic Astrophysics one, which is compulsory.
Galactic.
That aren't doing Python. And I have no clue what they're going to end up doing.
Interesting.
Anyway.
Well, maybe they already knew Python.
There's then another equation that we had to do something with that did a bunch of shit. There's not exactly much of a description as to how it works, so I can't tell you. Then there's another one that does the same thing.
Do you have any like practical thing? Not practical. Any like conceptual things we can talk about?
No.
Like what actually?
Here we go.
is
Okay,
about?
I've moved on. Yes, there was a bunch of maths questions in the middle. I've reached other stuff.
Evil.
Look, we can talk about, because this question is just the 4 main features of the Milky Way. Isn't that lovely? I'm just rubbing everything out now. Okay. Bam. Bam. The 4 main components of the Milky Way in order of mass. So what takes up the most mass in the Milky Way galaxy? Go on, we can make this one a participation-y one.
Go on. Chat, what do you think? Write what you think takes up the most mass of the Milky Way. Sagittarius A star. Supermassive black hole in the middle. It's probably a good guess.
You think so?
Sagittarius A star. I see. Oh, is that what the black hole is called?
Yeah.
Yeah, that makes more sense. Yeah. Okay. Or is it just like the total of all stars instead? I don't know.
Well, you're wrong. The answer is actually the dark matter.
That
Makes
makes
up the most
sense.
mass of the Milky Way.
That makes sense. It was a little. Yeah, but that was not the question. The question was not what makes. Yeah. The question was
Okay.
not what is the most massive. The question was what takes up the most mass, which I guess is a bit of a confusing question because, like, do you
Yeah.
mean one
Well,
object or do you
the question
mean
was
what
actually worded
element?
as
Like,
what are the main components of the Milky Way, which I suppose is
see,
may have
matter and dark matter.
may have yeah. Um, so if we look at it that way, what's number 2? Given I'm looking at components, so you can group things together if you want.
Okay, so black hole.
Oh, I say that, and even then, it's still stupid because number 2 is a is the rotating disk of young stars and cold
Okay.
gas.
So we have to divide the Milky Way into some parts. So you've got a disk that is like that. It's not really like that, but you know what I mean. Kind of like that. You've got the dark matter in between. What's next? Go on.
A roughly spherical central bulge,
Okay, so
which
you've
is
got like
essentially all the stars
ball.
immediately orbiting the central black hole.
So you've got a ball. So
And
like if you
then,
look at it sideways, it's like that.
yeah. Yeah, so essentially, if you look at the galaxy side on, you have it flat, and then
It's
you
like
have like
that.
a
It's like
middle
Saturn.
ball in it. Yeah.
Which makes sense.
Yeah. Oh, bulge. The galaxy's bulgy wulgy. And then number 4 is essentially just all the other stars. It's actually worded as globular clusters, which essentially means all the other
Just like
stars
there's
because they tend to be in
some
clusters.
balls like that.
Bam. And that's that. So, so there you go. It's interesting to think about the difference between the stars in them. So you may have noticed the rotating disk was young metal-rich stars. I didn't say metal-rich, but they are. Those are just like where star formation happens a lot, and so you get bigger stars which are shorter lived, and also they will supernova, which releases the heavier elements, the metals. So when things start to reform around that area, you will have a load of metals going into your stars. The spherical bulge, however, has younger stars because all the material has kind of been taken by a big black hole in the middle.
Okay.
So there's less material to make them with, and they're older, they are less massive, and the things around
You
them
called
would
them
have...
younger stars.
What?
And then you said they were older.
The ones in the middle are older. The ones not in the middle are younger.
You called them younger.
I meant
Okay.
older. The ones around the central black hole are older. I think I may have meant to say smaller rather than younger. I think that's what the
Yeah,
confusion
probably.
was.
Okay, so there's smaller but older stars, and then you've got the newly forming ones far away, and then you've got the little globular ones.
Yeah,
How are
which
they?
are even older, because there's less material from there. So, yeah, those are the oldest ones in the globular clusters. So there you go. That's that.
Where are those globular clusters? Like, what does that mean?
Everywhere. They're just like spreads of stars. So each one of them contains like 1 million stars, somewhere between 100,000 and 1 million.
Okay.
Which is quite a range, but whatever.
But like visually, how do I? Because you like,
Essentially, they're
you've
more
got the
dense
disk
regions
is
of
easy.
stars in the galaxy. So you have your galaxy, you have stars all over it, and then you'll get like regions where there's a bunch of stars, and then more sparse one, and then bunch of stars, and then more sparse, bunch of stars. And that's the general idea. So a globular cluster is
see.
just where there's a bunch of stars, where
Okay.
the density is higher than average, I suppose. That's not going to be the technical term because there'll be a lot of areas where the density is higher than average. There won't be a globular cluster. So let's say the density of stars is much higher than the average or something like that.
It's a very wide boy.
Believe it or not, the next question is describe the age, composition, and distribution of globular clusters in the Milky Way galaxy. Let's see if what I just said was right, shall we?
Let's see. There you go.
So I'm just going to read this out. Globular clusters are old, roughly 10 giga-years.
Giga. I love
Yeah.
giga years. That's great.
Giga-years. 10 to the 9 years. For reference, age of the universe is 3 times 10 to the 13, I think. So there you go. They've been there a while, but actually not that long. Metal poor star clusters, each of a mass of roughly 100,000 to 1 million solar masses. So that's not how many stars there are. There's probably more, given that they're young and smaller. I mean, old and smaller. Jesus Christ. So, let's say roughly 1 million stars, shall we?
That's what
they're
small p is, by the way. It's momentum. Sorry, I'm distracted because they're talking about momentum in chat.
I see.
And I
so
just remembered
me using p is actually an issue. Fuck, I need to be more
this is
specific when I use a
momentum.
row. Okay, whatever.
And then rho is something different.
Whatever.
Okay.
So yeah, globular clusters, old metal poor star clusters. Metal-rich globular clusters form a highly flattened system and rotate about half the speed of the galactic disk. What's that got to do with anything? Who knows? The metal-poor globular clusters form a roughly spherical system about the galaxy and are slowly rotating. Not entirely sure what that means.
I'm not paying attention either.
Or the
I'm
relevance
looking
of it.
something else up.
Yeah,
Well, it depends on
essentially
the
there's
energy, but that depends on the frequency, champ.
there's more metal-rich ones, which are things that happen. Highly flattened system. Okay, they're going to be more flat then. So, like, as in flat in this case, meaning that they match the pattern of the galaxy. So, as we drew it, it was Saturn-like. So these will just be essentially flat, like the disk. Whereas the older metal poor ones will be kind of like they'll have essentially a height, if you want to call it that, along the rings. But it will still be like negligible to look at, but they have a height. What's this?
That's what?
I think that the older ones are, so the metal poor globular clusters are things that aren't actually in the galactic disk, from how this is saying it. So like you have that, and then you have globular clusters that are just like orbiting around the galaxy, but like not attached to the disk.
Okay.
I think that's what this is saying, which makes sense because I've played Space Sims. You see them. They're just floating areas of star formation, not necessarily completely attached to the galaxy itself, but they're still part of the galaxy.
They're just
'cause
kind
they're
of
still orbiting.
vibing.
Yeah.
Yeah. Okay.
I say that because they have that they extend out to about 50 kiloparsecs or more, which is quite far. So I think that they just about leave the galactic disk. But there you go.
Mhm.
That's globular clusters, I
About
suppose.
the thing that you're talking about here. Basically, what I'm finding, well, sorry, not what you were talking about, but what Champ and Abyssal are talking about is what I'm finding if I'm looking it up is that the energy squared of the momentum squared and then the speed squared is mass and speed squared, not is plus. Oh, fuck off. This is a what was it? Relativity. Special relativity. This is a thing in special relativity. And then because for a photon it's massless, so this part just falls away, so we find that energy squared is well, we don't even need to square anymore. We just do this. Which we can then write as the momentum is E over C, and the energy of a photon can be written as H, which is the Huygens constant. No, who's it? No, it's the H constant. What's it called? Who's it? Planck. There you go. The Planck constant. Which is, this is literally what it is. Over C, and then C over F, C over the frequency, speed over frequency is the wavelength. So we can change that into the wavelength, and then we have the constant over the wavelength. And that's a very basic way, very basic derivation, which I think is a bit confusing because like we just start with the, like we say, oh, m is 0, but then why? I feel like it's because I'm with you. I'm with you, Abyssal. Wave particle duality. Yeah? Why are you talking about wave particle duality? I think wave particle duality on its own isn't really quantum mechanics because it's just, it acts both as a wave and a particle. Quantum mechanics is more like seeing it as as statistics. But anyway, that's completely off topic, but that's what I find when I look it up. The momentum of light.
Sorry, my shit crashed.
And we do know that light does have a momentum, because this thing I found here is momentum can be thought of as an object's ability to push another object due to its motion. And a very good example is we have things like light parachutes or whatever it's called, like those big, the concept of like just a big light catching thing, and we can propel it with like a solar
Lasers.
sail. That's what I was thinking.
That too.
Like we use the sun, the light from the sun to propel us.
Yeah. Well,
but also I think it's the
kind of is
momentum that
different.
light has is so small that negligible, but not in this case or something?
I think that a solar sail relies on the solar wind more so than the light from the sun. So a
Is that
stream
true?
of charged particles coming off of it.
Okay.
But like but a solar sail does. I mean, light will have an impact. Like you can point a laser at a solar sail and it will work. It'll be incredibly slow. You need a big ass laser, but you can make it work.
Okay. But yeah, what I'm finding here is it says light carries a momentum in the form of energy, which is what we've written down here. But I think it's just so small that it's not useful. But I'm reading this thing. We're back to the old ways of not understanding anything.
Yep.
Just Googling.
Yeah, that's the I have more like explanation stuff I can do.
Okay.
And then maths comes back, so we'll ignore that. Because like,
well, it's still interesting to look at the maths if it's not a like, you know.
I mean, well, like this is just a massive rearrangement, and like, I'll tell you the steps rather than the equations.
If
that
it's
go
all
into that.
about
so
rearrangements.
yeah, you start with an equation. And then
well,
there's a
let's start with
fact
the
about it.
question. What are we talking about first?
So the question here is: consider an exponential disk with surface brightness I brackets r equals I0 e to the power minus r over hr. Find expressions for the radius at which the surface brightness has declined to half the central value, the radius r that contains half the total light, and then just say which is larger. And for the last part, there is no need to find numerical values for them. You can do so just from other things. And then the steps involved is you have your starting equation, and you have how that changes that drops to half the central value at radius r.
Can you tell me the like the equation that you had?
So the starting equation for this is I'm using a pencil. Hang on. I equals I0 e as in the exponential minus to the power
Euler's
minus
constant.
r over h suffix r.
Small r, large r, tall
Capital
R.
R's. Yeah, all of those are capital R's.
Yeah.
What is that equation? That I think is something to do with light.
Intensity?
Yeah, I think that's the amount of light received at.
That's the way. Yeah,
something.
it's how much. So I0 is, I'm assuming, the intensity at the point of where it is, and then I is like, let's say this is the place 0 where we have intensity 0,
like
and then we're at distance r. I'm assuming.
Yeah, like this could just be an intensity versus, as in a actual versus observed situation. Although the equation for that I think was different. What is this? The exponential. This is the exponential disk surface brightness equation. Let me Google that. Exponential disk surface brightness profile. Well, that's brought me some things. Surface brightness profiles. I mean, yeah, they're roughly the same equation. Exponential galaxies have surface brightness profiles described by an equation of the form, yes, what we've just written. What does it mean by exponential galaxies, though? Let's Google that. Exponential galaxies. You'd think I'd have, like, heard that term in the lecture, but no.
It's probably like the shape that it takes, right? Which is exponential, because it's the e. Because
It might
that
just,
like when you
I
were
think it's
asking
just
the
spiral
question,
galaxies.
read the question again.
Consider an exponential disk. Oh, it says it in the description. With surface brightness equation, find expressions for, and then the following. So it just says consider an exponential disk with surface brightness that. The thing is, like, I presume that exponential disks are a real life thing. Otherwise, we wouldn't bother be doing this. So I'm just wondering what they represent. Are they just spiral galaxies? Are they any kind of galaxy in terms of your disk that just turns out to be exponential? I doubt it. Unfortunately, the only things I can find which mention it are proper scientific papers, rather than like, this is what this is. Okay, a lecture by Yale. Topics that will be covered include exponential disks. Show me an exponential disk. Because of their close to exponential appearance, disk galaxies are often modeled as infinitely. What is that? Infinitesimally thin exponential disks. So essentially, no thickness, and they're all just measured as exponential disks for reasons unknown.
So what do you mean with exponential disk? Like it
I'm
becomes like, where is the exponential part? Is it because it's
surely
like
that has its own like description available online. Exponential.
is this just like the intensity of its light? Like the further away you
Disk.
go, this is like the center.
The galactic
Maybe
disk
mass
is
density, that
represented.
makes sense. That could work as well. I think they'd probably be like
The galactic disk is represented by an exponential disk
Smoke
where the surface
rises
mass
from the mountain
density
of
is
doom.
expressed as
The hour
equations
grows late,
similar to the
and
one we've got,
Gandalf the Grey
but not using the
rides
same
to
thing,
Isengard,
because mass density is
seeking my
different.
counsel.
Although actually they are kind of equivalent, so of course it is actually the same. For instance, so
yeah, that's what I was thinking.
like we've got that one there.
What if
The
we
mass density equation is just substitute I for what I think is sigma, but I'm not entirely sure.
Rho?
No, it's a backwards Z.
What? Wait.
I'll draw it big and accurately, so it looks like
Oh, yeah, that and a backwards E. You think you'd say
like that.
that's not a Z. How's that a Z?
I don't know.
That is a sigma, yes.
Yeah.
Fushbra.
Fushbra. So yeah. Anyway, because the surface mass one is just that, and then
One day,
put in
the
another sigma
Fushbra
here,
branded
and then
bra.
E minus R over RD, which I'm presuming is similar to HR, but whatever. Anyway, that's the same idea, because those two are an earlier question. This involved interchanging the two of these, because they kind of are, just by changing one of the constants, I think, and then you get the same thing, because stars' mass and luminosity is linked. So you just do a substitution in there and you get the same rough
Yeah, that's what I was
situation.
thinking. Okay. So yeah, what I'm assuming this means is the further out you go, because it's a negative exponent, right? The further you go, the smaller it gets, and that the center is like the peak
Yeah.
of the like exponent. Well, the closer to the center, I guess you go. Whatever.
Yeah, I think that like disks
Well, I guess
happen
it's
to be
1.
exponential a lot of the time, and
I guess it's at 0, which
you model
intersects
them
at
that way.
1. Does it intersect at 1? Does it only intersect at 1 if this is E? So it intersects at whatever this is. Whatever. That doesn't really matter. But yeah, it intersects at a certain thing, and that will end up being I0, and then the further you go, the further you go to I. Yeah, that makes sense.
Yeah.
Because this is 0.0, wherever it... And then this is the intensity, and this is actually R. Well.
Yeah.
R, okay,
So all you
yeah.
actually have to do for this particular thing is, so you have that as the original one, and this is the new one. You're finding the point R where...
What was the question, actually?
So the question is, find the radius at which the surface brightness has declined to half the central value. So all you need to do for that one is I0, and then you have to find what R is in this equation when E
Yeah,
to the
so
power
you're looking
minus
for
R over HR is equal
this,
to
right?
1 over 2.
You're looking for
So
where
then,
when this is correct, right? Which, yeah, that is, yeah, because then these fall away, and then, yeah, that is what you've written.
yeah,
Um,
yeah. So essentially that eventually, as you do maths, comes out
what is
as...
HR?
Good question. Don't have to do anything with it here.
Is it...
Essentially, you just rearrange that into
Yeah, it doesn't really matter.
that. So R equals HR natural log 2.
Yeah, so you take... Yeah, you move, I guess. 2...
How does that work is the question. So to get rid of an E, you do the natural log of something. So this would turn into minus R over HR.
Why is it
equal to...
ln2?
That's what I'm
Surely
wondering.
that's
Where did that
ln
come
1
from?
over 2. Or like...
Yeah, because...
Well, or you need the ln1 as well. You know?
Could you not just do ln1 over 2? Well,
That's
what is
what I was
ln1
thinking.
actually? Because ln1 over 2 is equal to ln
Oh,
1
is ln1
minus
0?
ln2.
The log of anything on 1 is 0, or is it the other way around? The log in anything in 0 is 1.
I think log
That's
of
how it goes.
1 is
Yeah,
0.
log of...
So you would just split that out into ln1 minus ln2.
Yeah, is 0. There you go. That's what I was
And then
thinking.
you would
Okay,
just...
so...
yeah.
Yeah, so this
And then that's
part
0, so you're
goes
just left with that.
0,
So you're left with minus
and
R
then...
over HR equals minus ln2. And then you just rearrange it, multiply it, swap the plus and minus signs around. Which is cool.
And then the nice part of doing a log of a product is you can make it a sum of logs. So it becomes ln of 2, and then the E and the ln cancel each other out, so you just have the minus R over HR, which you can just move to the other side then. So you end up with R is the natural log of 2 times HR. Is that correct? Is that what you have? Yeah, that's what you have.
Yeah.
Just getting rid of my drawing here. Yeah. Logarithms are quite cool. They're an interesting tool because a lot of the time you'll find e's exponential, you find Euler's constant. And a lot of the time you want to get rid of that because it's really fucking annoying. And it's really easy when you can just say, like, we'll just take the natural logarithm of everything, and then it just gets rid of a lot of stuff. And now you just have, like, this constant of the natural logarithm of 2. And then, like, it's really easy. Depending on whatever your HR is, whatever that means, you can find... And that's the spot where the intensity of the light, the luminosity, whatever you want to call it, is half as large as it is at the center.
Yeah. The next question is then the radius that contains half the total light, which involves integrating and is quite long. So I
Yeah.
suggest we don't do that.
So you'd have to integrate over from the center to, and then that like to R, and then wherever. Yeah, I mean it's not too hard, but yeah, it involves integration.
Yeah,
Which
like it's not long.
honestly,
but
maybe
it's-
we should just do like a. Maybe we should just talk about calculus at some point, and just talk about integration.
maybe. Like,
Because it's
yeah,
like it'd be a nice refresher as well for me to
yeah.
just talk
I'll see if
about
I get a quiet
integration.
week.
Yeah. Yeah, let's just teach Emma calculus. That could be
Sure.
quite interesting.
Should we go through this one then? Okay. So the starting point is
Well, we have the
kind
same.
of the same.
We're starting with the same formula.
We're looking for. No, I've started. That was the line from the previous one. I thought that looked wrong. So yeah, start with the same formula. So
But I feel like without any background on integration, this will be quite difficult, like quite confusing. But we're looking
it's easy
for
enough to
wherever
explain.
so inside of this disk. So let's say there's this disk. We're looking for the volume. Let's just do it in 2D. All right. We're looking for the volume in. So from the center point to at some point, some value of r. Where this volume underneath the, like in this area is half of what it is at the center. So like half of this value over here, which is I0. And then this, wait, let's do it. Let's use a bit of color. So you want to know where the red area is, which is like the integration over this part, is half of I0. Whereas earlier we went for the value that is where this value is half of R0. And now we're looking for the entire part, like the sum in total is half of I0. And I think that is like the main difference. And then if we ever look at integration, a good thing is if you take the integral. So taking an integral, it's something you can do to a function, just like adding something or subtracting or whatever. You can take the integral of a function, and that you'd take the integral of some function, and you'd take it from a certain point to another point, right? So let's say we're taking it from, well, I guess we take it from 0 to wherever r is, and we're looking for this r. Which gets a bit confusing, but you know. So, and we want to know where this sum of this integral is I0 over 2, and then our function is this function. Right?
Yeah.
And then I0 is going to be, like, I0 is a constant, so it comes out of the integration and it falls away again. So we're just integrating over this exponential, right? I guess we're integrating over r instead of over capital R. Well, I guess for value we should have like r. What are we calling it?
I'm just saying, right? This answer gets complicated.
Yeah, I don't think we should do it because like integrating over it's a confusing integral because you need to do like integration by parts to do the exponential one, like because you need to do it inside the exponential, which is really fucking confusing. It's not a simple integral, but I think what is important is what's important is basically we're integrating over, oops, I0 e to minus r over hr. How's it? Yeah.
Hmm.
Why is it 2 pi r squared? Oh, because we're looking at the volume. God. Good
Yeah.
luck at the dentist, Emma.
It's an interesting one.
Why is the... Oh, yeah, so you do put the exponential in there afterwards, which is I. Oh, yeah, okay, because you're integrating over I, and then you have to also, because you're changing... Okay, because it's a three-dimensional... Fuck, I fucking hate integrals. I haven't done this shit in ages, and it's horrible. Yeah, so we're adding 2 pi r... Is that r squared? It's quite small. Oh, no, it's just r... I see. It's just r accent.
Yeah. R
Because...
prime is what people call it.
Prime, okay. Well, it's because it's because it's confusing if we integrate over r, and also have a constant of r that we're going to. So because this is the one that we're integrating over, like, and then we're filling in r that is the one that we're looking for, which is just one constant, one number. Do we just want to talk about integration instead? I feel like just talking about basic integration is simpler than actually doing this. But yeah, basically, this is a really annoying integral to do. The I0 part basically falls away, right? Or is that later? Yeah, well, whatever. Basically falls away at some point. You can take out the 2 pi because it's not dependent on r. So you're just... God, it's a real fucking ball-ache one to do, huh?
Yep.
Because it's fucking... Hello?
It's a nightmare. Which is again something I need to go through in my free time.
Yeah. Because you need to integrate with this one, the exponential, and then fucking... How the fuck does integration by parts even work anymore? You have to do a...
Well, the relieving part about this particular
call
module
this
is
X.
that it's a 24-hour exam using whatever notes you want and whatever resources you can find. And I have a Wolfram Alpha membership.
What does that mean?
They give it you on a day.
Exam?
Yeah, they give it you a
You just
time
do
on
it
a
at
day. You
home.
have to send it by that time the next day.
I see. Okay. I guess that's good, yeah.
Which is nice, but also makes me think, Jesus Christ, what are they going to ask me?
Yeah, that means like, oh god, you're gonna have something horrible.
And how do I do
But also,
practice
it's
papers?
more realistic because that's how you're gonna be doing it. And like, if you're ever gonna... Like, it's not like you have to learn all this shit. Like, you have to know stuff. You can just Google. But you need to know what to Google. But yeah, you have to like... You have to like substitute that for X. And then you have to figure out what just R is, which gets kind of confusing. And then that, whatever isn't that, you can take out of it. Because if you do this, you get something like this. which then, oh sorry, no, you're looking for, yeah, you're looking for this, and then so this r will become minus x h r, and then you'd have to take the minus hr out, so you'd end up having that, an integral of 2 pi minus 2 pi h r. That already looks a bit less daunting, but it's still fucking horrible. From 0, and then we're going to x. But also, yeah, you need to change the integration, but if r is going to capital R, then I guess, is that even correct? Why would it be? Oh, sorry, it's going to capital X, which is fucking annoying. Which is capital R over. Yeah, it's a really fucking annoying, and this is even before we're actually doing any integrals, because then you have to integrate by parts, which means being really fucking annoying, because it's if you have two. I want to remember this because it's been so long since I've done it. I want to like remember what it actually was. Fuck off. Okay. It's like the integral of fx times gx is the... No, that's not true. One of them is already a derived one, I think. Is that true? Wait, let me look up integrable parts. Anyway, you talk about something interesting while I try to remember how integrals work.
I mean, I've sent you the solution.
I know, but I'm trying to just figure out the general.
Yeah, I'm not entirely sure what really happens there. Anyway. I mean, the only thing that we've not... oh, no, there's two bits we've not done that I noted here. So, there's some information on the Milky Way disk, which is interesting. So, just describe the composition and give the radial and vector section lengths. Scale lengths, I should say. So, you have... Excuse me again. Sorry, I'm going to have a drink before I go through this. Yummy. So you have some basic parts of the disk. The so-called thick disk, which is about 1 kiloparsec high. When you remember that the galaxy is, I don't really know. What is it? I think it's like 50 kiloparsecs maybe across. Then you have 1 kiloparsec in height, so you've got about a 50th of it. Then you got a thin disk, which is about a third of a kiloparsec. I'm not entirely sure what those bits are. Like, let me find a picture and then draw it so that you get an idea of what I'm actually talking about. Milky Way disks. Bam. And I'll get rid of this equation. Redox is having fun with that. I don't need to even worry about it. Well, I do, because I need to answer questions on it at some point. Which will be fun.
Well, I mean, I'm just remembering how integration by parts works. It's basically like you... you do a, what the fuck is the word? You take a derivative. You take a derivative of one, and then you integrate the other.
So just pretend I've drawn that better. So the thin disk is essentially the main part of like what you see as the arms, say, of the galaxy, or the disk part of the galaxy, which is just where most of the stars are. It's nice and it's the main bit, you know. It's the bit you look at. Isn't that lovely? Woohoo! The thick disk is then essentially in a region around that where there will still be some stars, but it will be a lot less dense. So the thick disk will have the most volume of everything, but it will be pretty empty.
What is this? I'm just stupid.
Nice.
I was being confused because I was trying to write down how I learned it, because I remember learning it with F and G, and then people are doing it with U and V, and that was confusing me. And also they were writing down like they had it so that F and G were the original functions, and then but then you'd have to have like an integration on this one and on this one, and then there will, if this one was not a derivative, but if it is a derivative, you can just not like it. This is a simpler way of writing it down than the way I had it seen, and this makes more sense. Anyway, it doesn't matter.
Yeah. Sure, those were some words.
Yeah.
So there we go. Did you like the bit about the thin and the thick disk? It made kind of sense, to be honest. Not much really to it.
It's interesting. It makes sense.
Yeah. And then the last bit,
It makes sense.
the actual last bit.
It's this. I mean, at the end of the day, it's just you have an exponential function and do some calculus with an exponential function.
Yeah.
That's what really happened here, was just to take the
Yep.
integral of this, and it's like, okay, but we're not actually doing that much, right?
I mean, I could just, if you want to know all the steps, I could put it in Wolfram Alpha and see the steps.
Nah.
Okay.
I mean, it's
Look,
like
the
most of the
last
steps
question
are
is
there.
about dark matter. So we just say what the dark
It's not
matter
actually too hard. It's just
composition and
integration of
morphology
parts.
is within 50 kiloparsecs. So it's the main mass component. We don't know what it is. Weakly interacting massive particle is what we think is what dark matter is. Roughly spherically distributed, with a density that falls as r to the power -2 at large radius, such that the rotation speed of the galaxy is approximately constant. Because, as we saw in the earlier equation, v squared, if we just used essentially galaxy mass, is equal to gm over r, and that implies proportionality between v and r. That's the symbol of the root of 1 over r. So when you have the density of the galaxy falling off as r is minus r to the power -2, you end up squaring essentially the square root. So you end up with just r. And so v is proportional to r, which is why galaxies rotate at well, not a constant speed. Rotate together, I should say. A constant angular velocity, I suppose I should say. Because when you look at a galaxy, compare it to the solar system, for instance, where in the solar system you have the Sun, Mercury is orbiting pretty fast, Earth is orbiting slower, Pluto is orbiting really slowly. Whereas in the galaxy, the inner stars go round, and as they go round, the outer stars are going around essentially at the same point. So it's more as a straight line like that rather than bendy. So That's
Is
why
it?
dark matter is why that happens, because
Doesn't it
there's
have
more
like long
mass.
tails?
The spirals,
Yeah.
yeah, but they maintain that shape.
Okay, so like it already has a spiral and it just kind of stays. It's not like dragging it out.
No, it
I
won't
see.
keep going and become a circle or anything, and it didn't start as a straight line. It was always a spiral and always will be.
I see. Okay,
And
that's
that's
that's quite
because
interesting.
dark matter keeps it that way, which is it's just how that is proportional, and because of the maths involved. Um, just because the proportionality goes up at that rate, it happens that they come out of it the same way. So you have
Okay.
everything going around together. I mean, I don't think it's exactly that, but it might be. So yeah, you end up just keeping everything together in the same shape. That's
Interesting.
the end of that bit of dark matter, and that is the end of what I hopefully accurately learned.
Hmm. That's quite interesting. We had some good parts.
Yeah,
It's homogeneous and
yeah.
isotopicus.
I mean, the galactic
It's
astrophysics bit is tough. Um, like there seems to be a massive contrast between the two modules I'm doing at the moment, which is fine. If you want a preview
I
of
mean,
what's coming
it's
up next
tough because
week,
it's just calculus.
yeah,
It's just annoying calculus. As
it's
long as it's
also
not
tough because
fucking
the questions
differential
are
equations, that's
introducing.
not too bad.
Yeah.
Honestly, in my books.
Well, next week, let me
Well,
check.
differential equation.
I can check
Anyway.
actually what they are.
I feel like maybe if we just have like a week, like if you have something that's like this, where there's not much to actually talk about, and it's just a lot of um like just a lot of calculus. And that's it, a lot of math. Maybe we could just have like a talk about differentiation and integration and like what that actually means, because it's a complex part of maths that is actually very important, especially in like the physics part. But it's not. It's like simple enough that you can explain it. Do you know what I mean?
yeah. Sorry, I've just confused myself.
Come.
Oh, sorry. So my confusion was I was thinking, wait a minute, I could have sworn I did this one because I've already gone through like what. So for the cosmology, I've already done what we'll need to say next week just because of how my timetable works. Um, and I was looking at the solutions and I was thinking, wait a minute, this looks nothing like what I did. Not because my things were wrong, but because like it's just a very different thing. And I was thinking, I was there on Monday when we discussed this, and this is all that is. So I was thinking, where does it all look so different? But it is the same thing. It just looks very different when you use computer-based stuff to actually handwriting it. And there's a lot of words in the solutions, which is helpful. Like I can really like go through the differences between the two modules. One of them is a lot easier than the other one. Cosmology so far has been a lot simpler in terms of the questions that have been asked of me. However, also they've been a lot clearer and I feel like I've learned a lot more from them. For instance, so spoiler alert, next week Cosmology will be discussing the FLRW metric, which is essentially geometry of space-time.
Okay.
Quite interesting, to be honest. It's a lot of matrices and stuff, and converting between them. And the questions after that lecture, there were two of them. One of which was to show how you can link the three potential geometries of space-time into one equation, and the other was plotting objects on a positively curved space, essentially plotting objects on a sphere. Which, are useful things to know and are good. So there were 2 questions in that, which took up about a page. My galactic astrophysics questions for the same week about fluids, there are 5 pages of questions.
My God.
And every single one of them looks like it's a mathematical rearrangement.
Hmm.
So the first question isn't too bad. It's explain the meaning of the Lagrangian derivative, which I'm pretty sure is, if I, because there's 2 of these. There's Lagrangian and there's
Lagrangian.
Logian. That may be its name. I got it wrong. And these are used to describe fluids. One of which describes fluids going through a region. So Eugrarian or whatever it's called, Eulogian something, describes fluid as it goes through a volume, and you are observing the volume and seeing how the fluid acts within that volume. The Lagrangian derivative does something slightly differently, where it observes the fluid over time. So if the fluid moves, it doesn't care. It's like, okay, the fluid's moved, that's being observed. You're observing the same fluid over time. So it's different in that regard. So I can answer that question. And then there's a rearrangement between Lagrangian and Eulerian. There it is. It's written down.
Eulerian. I'm assuming it's Euler.
Yeah,
Those are people that you should
sure.
probably know.
Whatever.
Euler and
I'm
Lagrange.
pronouncing it
both
how
of
it was
them
pronounced by the lecturer. I think.
Yeah, that doesn't mean they pronounced it correctly.
No. The thing is that the third question is a repeat of the first question.
It's not Euclidean, it's Eulerian. So it's Euler.
Yeah, Euler.
Yeah.
And then IAN, but whatever.
Famous mathematician and physicist Euler.
Yeah. So question 3 just goes into that. And then question 4 wants me to consider the potential. I don't know what that symbol is.
In the 18th century.
Something equals 2 pi g pho 0 over 3 brackets r squared. Where pho 0 is constant and r squared equals x squared plus y squared plus z squared. So a 3-dimensional thing, and then you do shit with it. I need to do some reading about that. Anyway, I don't know what's coming up for that, but essentially that's a maths rearrangement. The next question, find the mass distribution corresponding to the potential that, which is another maths rearrangement. Question 6, for a system that does that, verify that these are a potential density pair, which is another mass rearrangement. Question 7, total potential energy of a spherical distribution of matter, that is that, blah, 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 blah. Show that the potential energy is that, mass rearrangement. Question 8, mass of the sun is that, estimate its average internal temperature. That will be an equation I don't know yet. Cluster of galaxies, the virial radius of that and is moving at that. Estimate the mass of the cluster in solar masses. That will be using one of the equations we did today, I think, rather than one of those. Linear growth, solve the equation for linear growth of perturbations derived in class, another maths rearrangement. And then we get onto section B. So that's the first page. The second page of 6 is titled B, longer questions.
Of course.
Of
course.
So the first question, show that the circular speed is this, which is maths. Determine the variation of VC with radius of both small and large values of r. Maths. Sketch the rotation curve as a result. Kind of maths, but a bit different. Find an expression for the ratio of density. Maths. Consider the potential. Show that this corresponds to that. Maths. Find the asymptotic form of circular speed at that and that. Maths. Show that the density at radius r is that. Maths. Find an expression for the ratio of the mean density, that. Maths. 2.13. Consider this. Do something with that. Maths. Show that that corresponds. Find the asymptotic form of this. Maths. Is that the same question? Okay, 2.3 is a repeat of 2.2, so I don't need to do that. So half of these seem to be repeats, which is nice. Then you get on to question 3. Section C, sorry. Now, you may remember section B was titled longer questions. C is
Are
just
these, like,
titled
even
long
long?
questions.
Oh, so are they less long?
Well, who knows?
Interesting.
There's 2 pages of these. First one, maths. Second one, fill in the missing steps in the derivation of the Poisson equation in the notes. Maths. 1.6, consider this potential. Find the period P, maths, and show that P is independent of R, maths. Show that stars on purely radial orbits undergo simple harmonic motion within the same period P, maths. What do you deduce about the period given the potential? Kind of maths. Given that density is constant, how does a star know to orbit around a particular point? It's a good question, not maths. Consider this potential. Show that this is true. Haven't we already done that one as well? Yep, that's a repeat as well. So 3.17 is a repeat of 2.13, which is a repeat of 2.11. Fuck me. There may be more repeats in this later on as well. This one isn't a repeat at all. Fuck me. That's maths. Go from that. Okay, that's another one of those questions where it's a complete lie at the start, what it's about, and then goes on to something else. More maths. Hint, derive mass r from d phi dr and show that it agrees with the expression calculated above. Now, you may think the expression above is something simple. Oh, no. The expression above is phi equals minus 4 pi ga squared b squared fo 0 over b squared minus a squared, open brackets, b over r arctan brackets r over b brackets minus a over r arctan brackets r over a brackets plus 1 plus a half the natural log of r squared plus b squared over r squared plus a squared. What a lovely equation. Take me half an hour to write it out. And then section 4, because it goes section A, section B, section C, section 4, is examples of questions that may come up in the final paper, which are also both maths, should say. Anyway, that's for next week. Isn't that an exciting journey into galactic astrophysics? And also I have an assignment to do for cosmology alongside that, which we won't discuss here because that would be academically dishonest. So, so hey, there we go.
In the meantime, I've been looking at basic calculus again with like limits and stuff.
And unity, I hope.
Continuity. Is that what you mean?
No, unity.
What's unity? What do you
Because
mean with unity?
the answer to the question that I sent through encloses our approach is unity.
What the fuck does that mean?
I have no idea.
Just one.
Anyway, job done. Claps hands.
I think it just means it approaches one, right? Surely, because unity. What else could it mean?
I don't know.
I think that's what it means. Anyway, but yeah, I was looking at limits and squeeze theorem and stuff. Is what I was looking at right now. I've forgotten all of this. It's quite good. We've already seen this.
Oh yeah, I think so. Because it's just saying the expression in square brackets is unity at r is infinite, which would be and what's in square brackets is 1 minus brackets x plus 1 brackets e to the power minus x. So as the e to the power minus x approaches e to the power 0, that approaches
That's what you
1,
said.
and so it becomes 1 minus 1, which equals 0.
I love limits because it's a lot of
Wait, but that's a multiplication,
fucky
so the entire thing
shit.
becomes 0 if that equals 0, so it becomes pointless. Fuck
But
knows.
it's
I'll have to go
limits, so
through.
you can fuck about with it. So you can just be like, we're just gonna forget the smaller part, and we're just gonna look at the larger one. Things like that. I love how stupid limits are. But it's a very interesting concept, which is very very cool. And then from limits you go into things like integrals and derivatives, which is very interesting because we learned that how I was taught it anyway was you learn derivatives first, right? Because they're like, okay, you're gonna do your derivative and it's a small change and until it's an infinitesimal change in your thing, and then that's very cool, and then from there on you learn the integral is the reverse operation to the derivative, well, the inverse even. So you learn it like that. But actually the integral was like they came up with the thought of an integral before they came up with derivatives, like just historically, for completely different reasons. And then at some point some guy was like, hey, wait a second, these
This is
are
useful.
yeah, these are linked to each other, which is very interesting because also they have very different meanings. Because one of them, let's say you have this function, the derivative gives you the rate of change of the function, whereas so if it's going from flat to less flat to less flat, it gives you like how quickly is it doing this. Whereas the integral gives you just literally the area under the function from a specific point to another. Which it's such a different concept. It gives you completely different concepts, but somehow they're related, and it's really really cool. To be honest. So yeah, maybe we should next week we should talk about limits, and then I don't know. Okay. Here's an idea. We talk about your stuff, right? Whatever your shit is.
Yeah.
And then we also go through calculus. We do some basic calculus stuff.
Sure.
Like we start with limits, and then from limits we move on to to use limits to define derivatives and stuff like that. And then we talk about like that kind of stuff.
Well, I said in my tweet, my stuff and whatever nonsense Redox wants to. So
Exactly.
this we've decided what that is at the end. Yeah. Nice. There we go.
There you go.
Good job.
I'll have a look to refresh myself about limits by next week so we can talk about it. That's good. I've also done like most of the things on different layers so we can go through what we talked about. Like some of the early ones I actually removed, but this is we talked about homogeneous and isotropic stuff.
Yeah.
We've got the to prove that it was isotropic. If it's isotropic everywhere, it's homogeneous everywhere. And then the light clock, which we talked about, which is quite interesting. And then this thing, which you fucking will get back to at some point, maybe. Maybe next week we will bring it back up. Who knows?
Maybe.
Who knows? This, which is not related to anything, and then this, which is interesting. Integration by parts. And also I did get rid of the other part because I wanted the other part to still be there. But it's yeah, that was good. It was good. Oops. Reminding me of calculus. That was nice. Right. Are we done?
We're done. Good work.
Yeah. Let's leave. Um.
Ugh, I can go off screen at last. Lovely. Oh. Ending soon. Jesus.
I'm looking at 3 blue, 1 brown. I swear they
Of
had like
course.
a calculus thing. Maybe they don't. But they have a lot of good physics things. They have like good oh yeah, they have like some linear algebra things which are really nice. Explanation of like vectors and stuff, like basic stuff like that. They have differential equations, which is very, very nice. There's a lot, but I'm just looking through the playlists, but there might be some better ones.
Might
There you go,
be.
Essence of
Right.
Calculus.
Enough. I have a 9 a.m. tomorrow.
All right.
I need to go to bed.
hell.
That's what
Where are we going?
I normally have a 9 a.m. tomorrow, which is why I suggested this day. But it turns out I have my project meeting at 9 a.m. tomorrow, which is
Oh.
kind of annoying because I had one today at 5 p.m. So,
Sag.
so I don't have anything to discuss for this, but I should turn up.
Well, where are we going?
I don't know. Psycon playing Playtop.
That's what I was thinking as well.
Bam! I've started it because Lord save me. I've
So
reached
yeah,
my
will we
limit.
do will it be Tuesday again next week? Is that the new plan?
Good
Tuesdays?
question. I may decide otherwise. I'm not quite sure. Like Tuesday's
Okay.
fine if we do it at 7, because I mean it's not late now. I can just go to bed. Whatever. It's great.
Yeah.
So yeah, Tuesday's good for me.
Okay. So yeah, next Tuesday, 7 BST, 7 p.m. BST. That is just like today.
Yep.
And we'll talk about more science stuff, and I'll talk about limits. I'll make sure I know what limits are.
Yeah, I'll try and get the
be fun.
interesting bits of the of the fluid stuff in whatever
Yeah.
that may be.
Yeah. It's good. Right. We're gonna send you over to Psycon, who's doing some crazy play up shit. He's automating pies at the moment, which is very cool. You don't need to apologize, Shark Dog. It's all good. Remember, Wheat is also streaming on his channel, so go and check Wheat out as well. Because if you want to see his notes, because he's also writing a bunch of notes that are very interesting and more in depth than what I write down usually.
Potentially.
Well, yeah, because it's usually like more exact things, and I'm just writing whatever shit I can think of. So yeah, we'll see you next week. Bye.
Raid's gone. Get out
So
of
bye.
here. Bam.